Moich, I'm audible. Hello, all day Moich. Hello, Moich. हेलो हेलो।
हेलो हेलो।
जी मोहित जी बोल रहे
हाँ मोहित जी आ रहे हैं, मैं इधर ज्वाइन कर लिया। मैं इसके
ओके
साहू बोल रहा था, तो ये कंप्यूटर से हम करेंगे आज।
ओके।
ठीक है, मोहित आ रहे हैं। वो बैकग्राउंड का थोड़ा मेल कर देंगे, बैकग्राउंड
कैसा बैकग्राउंड?
जो इसके बैकग्राउंड हमारा रहेगा।
कैसा बैकग्राउंड आप बताएंगे एक बार?
जो कल हमको बैकग्राउंड दिए थे ना, जो वर्चुअल चेंज करने के लिए, वर्चुअल बैकग्राउंड।
नहीं नहीं, वो मैंने नहीं दिया था आपको।
वो विभा मैडम शायद भेजे थे।
हाँ, विवो मैम से ले लीजिए।
क्या भेजा तूने बैकग्राउंड?
आप विवो मैम से मंगा लीजिए।
ओके, इट इज विजिबल। हाँ, इज इट ओके नाउ? दीवाने
परमिशन मिली।
হল ডি এসছে তো?
হ্যাঁ স্যার।
একটু ফোন করি।
স্যার মিউট করে দিন স্যার।
Good morning.
Good morning.
I'm Alpana.
I am Dr. Jyoti Shankar Bandyopadhyay from Vidyasagar University, madam.
Nice to talk with you.
Madam, you are from?
I'm from MG Science Institute, which is affiliated to Gujarat University.
Okay, thank you.
I'm at Ahmedabad.
Oh. I am from Midnapur, West Bengal.
Yes, sir. Yes.
Yes.
Good. Mohit?
Yes, ma'am.
Yes,
ma'am.
Yeah, I think Vinay sir is yet to join, no? Have you reminded him?
No, ma'am. I called to him, ma'am.
Yeah, please do that.
Namaskar.
Good to see you also.
Good morning, sir.
Good morning. Good morning. এবার দরজাটা একটু পর্দাটা ফেলে দাও, মানে ওখানে একটু কোথাও মানে ম্যানেজ করতে হবে। ভালো তো থাকতো। সুমন এলো না, সুমন দাস, একটু সুমনকে ফোন করো তো। আমিও মিউট হয়ে যাই। Good morning, Professor Shegal. I am Dr. Jyoti Shankar Bandyopadhyay from Vidyasagar University, West Bengal.
Namaskar, Dr.
Namaskar.
Bandyopadhyay. Thanks and very good morning.
Very good morning to you, sir.
Yeah, Namaskar, Alpana ji. So, are we waiting for other presenters to join? Actually, still that Hall A plenary is going on.
Sir, shall we start, sir?
Uh, the problem is even we are waiting for participants. We are supposed to have 6 participants.
Yes, sir. But in current session, we see only 3 participants. 3 is not here.
I
4,
only-
sorry, sir. 4, sir. 4.
But our time is 11:30, no, Mohit?
No,
No,
11.
ma'am. 11:15 to 12:45.
Oh, okay, 11:15 to 12:45. Okay. Let's wait 5 minutes, sir. What do you say, Vinay, sir?
Sure, ma'am. Sure.
Meanwhile, did you ask Sehgal sir about what you were asking me? Sehgal sir?
हाँ जी बताइए.
हाँ, ये कह रहे थे कि since there is not any lead talk in our session, if you could just give a brief
Brief
introduction
about.
in 5-10
Yes,
minutes
sir.
about the topic, just climate resilience and remote
Yeah.
sensing.
Disaster.
Yeah, I need to give, but we are only 2 participants and a chair and co-chair. So,
हाँ, हम लोग
बताना
wait
किसको है?
करेंगे सर, हम लोग वेट करेंगे थोड़ा.
हाँ, थोड़ा वेट करते हैं.
जी सर, जरूर जरूर. सर आपने वो मार्किंग शीट आपके पास है ना सर?
हाँ जी. Yeah, one more has joined.
Yeah.
So,
No, I think some of the other delegates will also join. Yesterday I was attending some of the sessions and there were like 20-25 people, you know. तो अच्छा रहेगा अगर थोड़े बहुत join कर ले. Shall I leave from here and check out the plenaries to see if it is over?
yes, please. Yes, please.
Yeah.
Plenary is over, ma'am. Hello. Plenary session is over.
That session is over.
Yeah.
Sir, one delegate is not picking my phone. So shall we start, sir? Sir, one delegate is not picking my phone. Shall we
Okay.
start, sir?
Let Madam Alpana join back.
I'm back, sir.
Okay, Madam, shall we start? I
Yes,
think,
please, sir.
yeah.
Okay. Namaskar and good morning to all. A very warm welcome to the chair, co-chair and delegates at this national conference on Geomatics and integrated technology to empower citizens towards self-reliant nation. Myself, Mohit, working as scientist C in Punjab Remote Sensing Center. Here we begin with technical sessions T6A, Disaster Management and Climate Resilience. May I request Dr. V.K. Sehgal from ICAR and Dr. Alpana Shukla, Professor MG Sai, Gujarat University, to chair this session. Now I am going to introduce our chair. Professor V.K. Sehgal has 30 years of professional experience in the field of agriculture research, including 17 years of postgraduate teaching. He is currently working as Professor Agriculture Physics and Principal Scientist Agrometeorology at the ICAR, New Delhi. His current research areas are surface energy balance of crops, monitoring residue burning, modeling pollution, drought monitoring, climate change and vulnerability, water use by crops, yield forecasting and crop insurance. He started his scientific career in 1991 as a scientist in Space Application Center ISRO, successfully carried out national level project on use of satellite images for crop monitoring and yield forecasting. He returned to academics by joining ICAR as a senior scientist in 2003 and he's continuing there. In between, he was on a deputation as professor and head at the National Institute of Disaster Management, New Delhi, and lead a team of faculty on training and research on meteorology, hydrology, and agricultural disaster. He has significantly contributed in the spatial crop yield mapping and forecasting by demonstrating linking satellite input with crop simulation models. He established and operating ICAR first satellite ground station at IARI, prototype a crop monitoring system for India, assessed vulnerability of agriculture to climate change and drought, and studying large area surface energy balance of croplands to improve strategy for crop water use. He is coordinator of ICAR Space Technology Cell and was co-author of Drought Manual of India 2009 and 16. His CREAMS labs provide the crop residue burning reports using remote sensing to the Ministry of Agriculture and Farmer Welfare. He has published approx 337 research paper in reputed national and international journal and delivered 142 technical presentation in international national symposia. He is a life member of 6 professional societies and guided 4 master and 4 PhD students. A detailed profile. Okay, thank you, sir.
Thank you, thank you.
Request you to please take technical session T6A. Now it's time to introduce our co-chair, Dr. Alpana M. Shukla. Dr. Alpana Shukla is the head of botany department at MG Science Institute, Ahmedabad, one of the oldest and largest science institute of Gujarat, accredited at A grade for 3 consecutive cycles, and from where Dr. Vikram Sarabhai started the physical research laboratory. Her teaching career spanned 3 decades with MG Science Institute and St. Xavier College here in Ahmedabad. A gold medalist in botany subjects, she also holds a diploma in Ayurveda, the science of Ayurveda and yoga for health. Her interest in remote sensing application grew when she did pioneering work of grassland mapping, monitoring using multispectral satellite data for her PhD thesis. In the last decades, she has collaborated in many projects of SAC ISRO, including mangrove mapping, global coral reef mapping, integrated coastal zone mapping, desertification and land degradation, reset Calwell, and chlorophyll analysis and other AVRIS as well as NISR projects. She has keen interest in environmental conservation and management and motivation student for the same. She is currently the vice chairperson of Indian Society of Geomatics, Ahmedabad chapter, member ISG executive body, vice president of Botanical Association of Gujarat, and joint secretary with the Indian Society of Remote Sensing, Ahmedabad chapter. The prestigious ISG President Appreciation Medal for contribution to geometric was conferred upon her in 2013. Looking at her just for spreading awareness of geometric application. Dr. Alpana has written book chapter for Government of Gujarat as well as other publication. She has more than 50 national and international presentation as well as publication. She has chaired session at several international and national conference and symposia. She is dedicated and enthusiastic IEEE GRSS member. She runs short-term geoinformatics course at her institute. Thank you, ma'am. Now request you to please take this technical session 6T6A.
Okay, thank you to the
Sir,
organizers.
sir, before starting technical session, I request to our chair and co-chair, because we don't have lead talk. Can you brief about today technical session, sir?
Yeah, sure. Okay, thanks to the organizers. I welcome to all the delegates to the ISRS ISG National Symposium Geomatics 2021. I also welcome my co-chair, Dr. Alpana Shukla ji. I welcome the participants to this session, as well as if there are any listeners, any other attendees into the session. A very warm good morning to all of you. We are here to talk, we are here to meet in a session on two things which are together. One is disaster risk or disaster management, another is climate change resilience. So as the organizers say that we should give a brief background. So whatever my understanding on climate resilience and how it is linked to disaster management and what are the linkage, let me talk a brief on that, and then I would request my co-chair also to give her remarks. And before starting on that, I'd like to thank the organizers for inviting me to chair this session. Yeah, coming to instead of disaster management, I'll first come to climate resilience. We know the climate change has actually, which has become more or less a reality, and now there are no more doubts about that. It is a thing which is happening at a much rapid rate, and it is going to have a very larger consequences for this planet Earth, not only for humans, but for all life forms and the balances and cycles which are going on across different subsystems of this planet. In climate change, actually, mostly people talk of what is the secular anthropogenic changes which are going to happen over longer period of time, like we are talking of 1.5 degree rise in temperatures and that kind of thing. But another important thing, which is basically of climate change, has implications for disaster management, and that is the increase in the variability of climatic events or climatic extremes and uncertainties. So extreme means more frequent and more intense climatic events may start happening. So though in the long term we are concerned about a rise in temperatures, decrease in rainfall, but in the short term we are more concerned about these extreme climatic events. So there may be extreme events of rainfall, and then there may be extreme event that a longer dry period. So there may be a situation that in the same place at one point of time, there may be a deluge or flood, and after a shorter period of time, you may be facing the extreme drought conditions where the crops may be wilting and the animals are not getting water to drink, and including other biota and vegetation getting impacted in terms of its productivity and sustainability. So this is where we have a linkage with disaster management. Coming to that, when we talk of disaster management, we always say that in disaster management, we have two phases of disaster management. One is risk management, another is crisis management. Risk management is all action which we take before a disaster event actually happens. And after the disaster event has happened, the hazard has struck and it has impacted some sector of the society or some ecosystem. Then we talk of what is crisis management, where we talk of how to provide response, relief, reconstruction, and all those kind of things. But before that, anything you do in terms of mitigation, adaptation, preparedness, early warning, increasing the capacity building, these are all related to disaster risk. And this climate change is going to change this disaster risk portion, because there would be changes in the local risk of extreme events. There may be heat waves, there may be flood, there may be drought, storms, as well as the general average climate may also change. So there may be shifting of vegetations, there may be a changing of rainfall regimes, sea level rise, and all this. And this may again impact one important thing which affects the vulnerability of the society, of the ecosystems. That is not only the environmental ecosystem, environmental vulnerability, but socio-economic vulnerability, the political stability. So those kind of things also impact the disaster risk. So one is you increase the exposures, you change the average situation, as well as you are making the societies more vulnerable. So this all leads to increasing the disaster risk. So there is a hand in glove situation of climate resilience and increasing the disaster risk. Now, coming to the issue that what is the commonality between these two? One is that both disaster management and developing or imbibing climate resilience in our development, these both are development issues. And ultimately, both share the same objective, that we want to build resilient societies, whether it is to disaster or to climate. Both may be happening in shorter, medium, and longer term, but both the management as well as the resilience, both of that we want to aim to build resilient societies. So whether it is due to natural disasters or man-made disasters, we should be able to overcome, as well as if there is a increase in extreme events, increase in hazard, still we should not lead to increase in vulnerability, so that overall disaster risk reduces and our societies remain resilient. And basically both disaster management and climate change, they face similar complexities and challenges for their management. And also both of them rely on the same measures and policy instruments. And both concern actually all sectors and human activities. That is another important thing. So there is a close linkage between disaster risk reduction and climate change. And we always say that whenever we are undertaking any policy decisions, developing any institutional mechanisms, implementing any line department programs, the disaster risk reduction should be such that those measures should be such that it should become a no regret option for the adaptation to climate change. So whenever we are talking of any disaster management measure, we should always keep in mind that how with small tweaking, it can also lead to adaptation to climate change and increasing our climate resilience. And if you spend on one thing and keep other thing in mind, then overall the cost and the time of adaptation reduces. So that is also very important. And whenever we are talking of mitigation or adaptation to climate change, it also reduces the vulnerability to natural and technological disasters. So both goes hand in hand. And of course, both rely on similar measures like adaptation and mitigation, whether you talk to climate change or whether you talk to disaster management. And both to a large extent have one important component, and that is of capacity building. If we are able to build the capacity of our masses, whether they are using our civil society infrastructures or institutions, or through our normal Panchayati Raj institutions, or of community at school level, at college level, if we are able to manage and build the capacity in adaptation to disasters, it will automatically lead to adaptation to climate change also. So, and I feel when we talk of in the context of ISG and ISRS, remote sensing and geoinformatics has played a key role in both of these issues, disaster management as well as in climate resilience. In climate resilience, an important thing is that nowadays we talk of mapping vulnerability, the mapping resilience of climate change of different sectors, like we talk of working for agriculture sector, how agriculture sector can be made resilient to climate change. So there a lot of informations come from remote sensing because we have now a sizable longer data sets on different type of crop situations which are happening over different period of time. And at the same time, it has contributed a lot in developing early warning, generating the evidences of whether your policies have worked or not related to your disaster mitigation or disaster adaptation. So I would say that this particular session is important, where we talk of both of these important aspects which go hand in hand. These are closely linked, and if we are able to build the capacity in one area, automatically leads to building capacity in other area. So with this shorter background, I would stop, and I would request my co-chair, Dr. Alpana, if she wants to make some comments.
Yeah, sure. Thank you, Dr. Sehgal. It has indeed been a wonderful introduction about our subject, that is disaster management and climate resilience. What you said is very, very true, that if we build our capacity, and because we all know that this is here, climate change is here, and if we can build our capacity, raise our awareness, and if we can do something good at one end, it is going to spread at other ends. And I would like to stress upon the fact that all ecosystems, I believe, have this inherent capacity of resilience. Given a chance, they are all resilient. Say, for example, after the tsunami, we saw how corals were died due to the tsunami, and given the time, they could rebuild, they could regenerate. And the same thing can happen to ocean ecosystems or mangrove ecosystems. We all know how resilient they are. So, and it is also a fact that anthropogenic pressures are increasing. So if we can understand how public and private and the government both together can raise the awareness of people who are actually the stakeholders, and therefore lead to an ecosystem whereby everybody is truly helping each other, rather than effluents and all this sewage and all this. If we can just control those things, extra overpopulated areas and all those things, if we can control that, then nature is going to get time to build its own resilience. We won't have to do much. What we have to do is on our side, I believe, that we have this capacity building, and nothing better than raising our awareness by sharing our thoughts and sharing what we do from such platforms as today's. Thank you very much, sir, and looking forward to some very good ideas about what work is going on at different parts of our country. Thank you.
Yeah, thank you, Dr. Alpana. I think with this brief background, we would start this session of presentation.
Sure, sir.
I understand that we only have Mohit is there. Mr.
Yes,
Mohit.
sir. I am here. I am here, sir.
Acha, Mohit is there. Dr. Alpana is there. Alka is, I find she's there. Then,
Sharmistha is not here, sir.
pardon?
Sharmistha. Sharmistha.
Sharmistha is not there. So 1, 2, 3, 4, 5 we have presentations.
Yes, sir.
And we are left with more than 60 minutes.
Yeah, and sir, I have actually, I would like that my co-author Tatsat is here. Tatsat
Okay.
is going to present on our behalf.
Okay, okay. So maybe we can have every 10 minutes of presentation with 1 minute or 2 minutes of interaction. So may
Yes,
I
sir.
invite Mohit? He is going
Yes,
to
sir.
talk on rapid flood inundation mapping and impact assessment over Ghaggar River,
Ghaggar River Basin.
Punjab, India using Google Earth Engine.
Yes, sir.
So Mohit, are you a student or you are a faculty?
No, sir. I'm working as a scientist, sir.
You are working as a scientist.
Yes.
You are working where?
Punjab Remote Sensing Center, sir.
Okay, okay.
Sir, my presentation is visible, sir.
Yes.
Very good morning to all of you. Today I am going to present my work, Rapid Flood Monitoring, Rapid Flood Inundation Mapping and Impact Assessment over Ghaggar River Basin of Punjab using Google Earth Engine. I am currently working on the project. The title of project is Near Real-Time Flood Monitoring over Punjab based on remote sensing approach. In this study, we are continuously monitoring flood over Punjab since 2019. And the objective of this study is estimation of precipitation for flood monitoring and impact assessment and disaster management decision support to Government of Punjab. I am Mohit, working as scientist in Punjab Remote Sensing Center. As we know, flood is the most frequent and vulnerable natural disaster that mainly occur due to both natural as well as anthropogenic changes. Flood mainly occur when water overflow its channel level over the area, and flood mainly occur due to heavy monsoon rainfall. As we know, nearly 75% of total Indian rainfall concentrated over short monsoon period from June to September. And extreme flood condition cause enormous damage in terms of human lives, environment, economic loss around the world. And as we know, flood happen irregularly over the world, but it is very challenging task to measure flood extent and hydraulic variables such as water level, warning levels, and discharge by conventional method during the flood period. And remote sensing technology provides compressive, synoptic, and real-time and trustworthy information to assess the extent of flood affected area and damage assessment over the large geographical area. The present study mainly focus on rapid mapping of flood inundated area using high resolution synthetic aperture radar data during 2019 flood and impact assessment in the Ghaggar Basin. In this study, I have used Sentinel-1 SAR imagery along with meteorological observation for this study. The main component of flood monitoring, mapping and monitoring are flood watch, satellite data planning, acquisition, satellite data analysis, and product dissemination. This is our study area, which are highlighted in green shaded area, and the latitude of study area is 29 degree 35 minute north to 30 degree 54 minute north, and longitude is 75 degree 10 degree minute east to 76 degree 52 minute east, and total area coverage is 49,978 kilometer square. In this study, I have used SATM data to see the elevation of the study area, and it found decrease from northeast to southwest, and the Ghaggar River rises in Shivalik hills in Himachal Pradesh, and it flows towards from east to west through Haryana, Punjab, Rajasthan, and more than 100 kilometers. Ghaggar River was considered as perennial river, but in recent era, it is considered as seasonal due to less and continuous flow. And the geology of the study area is The entire state is vast fertile alluvial plain formed by sediment transported by major tributaries of Indus, including Jhelum, Chenab, Ravi, Byas, and Satluj. In this study, I have used multiple data set like Sentinel-1 C-band, GPM daily data set, Indian remote sensing LEAS-4 data set, SRTM DM data set, and radar set. And in this study, we have used Google Earth Engine to process the such data, and for mapping purpose, we have used QGIS and ArcGIS. In this study, we have used Sentinel-1 GRD product for both season pre and post flood situation. March month has been taken as pre-flood, and 10 July to 31st July 2019 is taken as a post-flood period. And we applied some pre-processing like spectral filter, radiometric calibration, and terrain correction. Parallelly, we have used rainfall GPM data, that is 3 hourly base. 3-hour GPM data comes in 3-hour base, and but in this study I have used daily product, and we mask our study area, and we identify the threshold value to map the flood extent. After then, we computed flood affected area by using LULC image over the study area. Results and discussion. In the as we know, 2 sets of dual polarized Sentinel-1 set data have been used for detecting flood extent and mapping of flood. And as we know, water pixel have very low backscatter coefficient, and that appears darker due to specular nature of water against the microwave signal. During flood, we have taken around 117 randomly sampling point during flood period to identify the threshold value for both polarized image. And we fixed the range of backscatter coefficient value that has been applied to extract the extensive flood inundated area over Ghaggar River basin. We applied for VH around minus 22 to minus 30 dB value, and for VV we have applied minus 10 to minus 20 dB. And in such intensity below the threshold value regarded as open and floodwater, and whereas when intensity below the threshold, above the threshold value, that regarded as dry land. And in this study, we have observed that VH polarization is more useful as compared to VV polarization to classify the flood pixel. In this study, we have taken data from 10 July to 31st July, but flood extent was in its peak during July 20 to 23, 2019, and on July 27 to 2019. And a total of 13,822 hectares area was inundated over Punjab during these peak flooding stage. And most of the area affected during the flood was around adjacent to the Ghaggar River, because its narrowness at the several places passing from Patiala and Sangrur. You can see in the figure, Patiala region has been affected more as compared to other district of Punjab. In this study, we have taken GPM data set, daily data set, and GPM daily data set product is also incorporated to see the spatial and temporal variability of rainfall over the study area. And in this study, we have find out intensity and frequency during the occurrence of flood. And this result indicated that Punjab has received maximum cumulative rainfall up to 499 millimeter, and with mean rainfall around 291 millimeter during the period from 10 to 29 July 2019. And in this figure, you can see that the maximum rainfall has been occurred in the foot of the Shivalik Hills. And we also computed district-wise rainfall distribution of the study area. The district fall under the Ghaggar River basin receive maximum cumulative rainfall more than 240 millimeter during July 10 to 19. Sorry, 29. Sorry, sir, 29. And the maximum daily mean rainfall has been observed at Fatehgarh Sahib, and most cumulative rainfall has been observed at Fatehgarh Sahib, Patiala, and Sasnagar. Maximum intensity has been observed only in Fatehgarh Sahib, but maximum cumulative has been observed in three districts: Fatehgarh Sahib, Patiala, and Sasnagar. And additionally, we also monitor surface runoff over the study area, and the discharge amount of water cross. In this study, we have found the discharge amount of water cross the danger level, which was around 748.5 feet, and touched the level of 750.7 feet. And it's impacted a large part of agriculture and urban patches during this time. And in this study, we have found that the paddy was the mostly inundated by rainwater accumulation, flooding with low elevation and low slope. And we further validated our data set with radar set image and found good correlation with accuracy of 82%. And flood impact analysis can provide a useful tool to spot mitigation strategy. Conclusion. Remote sensing technology provides the information on spatial flood extent, flood damage statistics like district-wide flood and in affected areas, submerged crop, etc. And identification of flooding is very challenging task from satellite SAR imagery compared to optical system, because in cloud condition we cannot get the optical data. That time SAR data will be helpful to identify the flooded area. And near real-time flood indication mapping and monitoring using remote sensing data is a vital support to disaster management and authority to make a plan for rescue operation and rapid assessment for property damages, life losses, and to ensure food safety. And as we know, the satellite data with geospatial technology can provide an effective solution for better management. And integration of various hydrological and climatological data with different cloud-based tools or machine learning models can be useful for better forecast and also be future prospect of work in this research area. Thank you, ma'am. Thank you, sir.
Okay, thank you, Mohit. Thank you for a good presentation and good work, where you have used two kind of spatial data to generate evidence of the inundation which is happening. But because you are working with PRSC, so
Yes,
who are your stakeholders who need this information, or you are
sir,
providing
only Government of Punjab,
within Government of Punjab, which department and how they are using it?
Department of Agriculture, sir.
Don't you overlay the agricultural area to find out statistics of how much agricultural area crop damage might have happened?
Sorry, sir, can you repeat, sir?
You are only giving the inundated area information.
Yes, sir.
So one layer of agricultural area, if you overlay on that, you can actually find out how much is the agricultural area got inundated, crop standing might be damaged, and all that.
We are working on this, sir, on cadastral mapping.
No need to go to village level or cadastral, but overall, because ultimately your resolution is very good. You are working
Yes, sir.
with Sentinel-1, ना?
Yes, sir.
तो 20 मीटर पे आप काम कर रहे हैं करीब
Sir, 10 meter per.
10 मीटर पे कर रहे हैं.
Yes, sir.
So that is one very important information which the line department official may be needing. I open the presentation for discussion. If anybody else has any comments, they can raise the hand or.
My question was exactly that, who all were the receivers of this important, whatever knowledge that you have worked out from this, whatever conclusion, how did it help? And did you submit this data? That is exactly what I also wanted to know, that if because it was also in 2019, so if it could be of help to others later on, the farmers especially.
Do we have any other comment? If it is not there, I'll I'll conclude this presentation and thanks Mohit for the presentation.
Thank you, sir.
Now I invite our next speaker as well as co-chair. She has said that somebody else will present.
Yeah, Tatsat Thakur,
Okay.
he is here. Tatsat, are you there?
Yes, ma'am.
Please go ahead.
Yes. Good morning, respected chairs and all the attendants. Myself, Tatsat Thakur. I'm JRF from MG Science and working at SEC. Sir, my screen is visible, sir?
Yes, yes.
Yes. Today, and special thanks to Alpna ma'am for giving me this opportunity. So today I will start. Today I will presenting on the topic the role of remote sensing in data in monitoring of oceanic dead zones. So first of all, we'll start with the main background. What is the ocean ecosystem? Ocean ecosystem is the most stable and climate resilient. Ocean make the Earth habitable for humankind. Also, it influences Earth's weather and plays significant role in hydrological and biological chemical cycles. Over 3 billion people depend on marine and coastal biodiversity. Uh, and as per the World Bank report, globally market value of marine and coastal resources is approximately to 3 trillion per year, or about to 5% on the global GDP. But as per the last research, coastal waters are continuing deteriorating because of pollution and consistent eutrophication, which is expected to increase tremendously by 2050. And roughly 80% of marine and coastal pollution originates from the land, including agriculture runoff, pesticides, plastics, and untreated sewage. Uh, what is the main, how the dead zones will form? In coastal water, because of excess in nutrients like agriculture runoff, pesticides, plastics, and untreated sewage, it will it will cause of algal blooms. They will provide uh, excess of nutrients to algae, and the overgrowth of algae will happen. This leads us to eutrophication, which will sinks and decomposes oxygen for that particular patch. And because of that, the hypoxic zone will generated, and due to this, all the relevant oxygens is consumed, and it directly affect to the marine life. And focusing on to this geological, I mean, as we focusing on this geological evidence about this minimum oxygen dead zones, uh, they are not naturally recurring events for estuarine ecosystem. For example, we can look this big bay, and the hypoxia events become seasonal if nutrient inputs continue to increase and persistent. And one of the studies says that the dead zones are generated in either cyclonic or anticyclonic mode of water eddies. And now, as we all can see in this image, in the first panel, the high nutrient inputs cause the low oxygen. The bacteria and algal will blooms, and uh, in second panel, you can see that the lower nutrient inputs uh, is able to balance the oxygen level. So basically, it leads us to discover this hypoxia zones and then the reason behind it. Here we can see this NASA global map for dead zones. The recent studies says that there are changes in dead zones can vary from year to year by their size and exact location. The scientists estimated that there are at least 400 red zones, and they could be expected to rise in the future. Biggest and the largest red zones are Gulf of Oman, which is about 63,700 square miles, Baltic Sea, and Gulf of Mexico. And the most surprising thing is the overall extent of dead zones across the world is estimated to be at least the size of the European Union. Now to this the role of remote sensing. As we all know, the remote sensing widely used and gradually become the foremost means to monitor and assess desertification due to its extensive spatial coverage, periodicity, systematic data acquisition at finer spatial and temporal spectral resolutions. In this, optical imaging sensors are crucial technology for coastal remote sensing. Satellite remote sensors can map coastal ecosystem and their changes cost effectively, appropriate scales and resolution for minimizing the need of extensive field and ship measurements. Here I have listed down some sensors which we are going to use. MODIS, CWIPs for their spatial resolution and their spot coverage. And if we talk about our Indian region, our tropical Indian Ocean is the few coastal areas on Earth which host both natural oxygen minimum zones (OMZs) and human-induced dead zones. In expansion of these OMZs under climate change, we bring oxygen-poor waters near to the surface. This can alter the exchanges between OMZ waters and coastal shelf waters, which directly leads to dead zones. Due to this minimum zones, hypoxia is prevalent in Arabian Sea, particularly in summer and fall season, and in Bay of Bengal in winter and spring season, which directly affects to the coastal ecosystem. In 2016, Dr. Mini Raman has they have worked on this dead zones area. Basically, they have used SST and chlorophyll data for 1998 to 2007 time period. And they have identified ocean deserts in Arabian Sea and Bay of Bengal. So further extending this research work, we are working on some patches for Arabian Sea and Bay of Bengal using satellite data and in situ data. Thank you, sir.
Okay, thank you, Tatsut, for your presentation on role of remote sensing in monitoring ocean dead zones. So basically, currently the work which has been done in India is using a chlorophyll retrieval as well as from ocean color mapper as well as sea surface temperature. Is it right?
Yes, sir.
Okay.
So you can open your video. It's okay.
Yeah. My internet connection is not so stable, so that's why I have turned it off.
It's okay. It's okay.
No problem. No problem.
So, do you expect this oceanic dead zones happens closer to coast or it is away from the coast? I don't know. I'm not a vision man.
So basically, they are forming nearer to coast as well as from far away from coast also. There are some regions, I mean, for what we can say, there are some regions where this sewage lines are directly drained out. Some pesticides are direct. I mean,
Yeah, that is near to coast where the rivers are
yes,
actually.
exactly. So because of this excess of nutrients, this type of dead zones are occurring. And if we are looking for some kilometers away, far away, there is one possibility of less nutrients. And due to less nutrients, the nutrients are not reaching out for that particular place. So the temperature difference is there due to some particular season. The sea surface temperature is rising, and the lower marine species are ranging between, and they are working in between some sort of ranging temperature. So because of high ranging temperature, there may be chances of occurring these dead zones.
Okay.
So actually, as you asked, it is more closer. The dead zone, as we call it, is likely to occur more closer to the coastal region.
So my suggestion only would be that further, once I understand whatever map he has shown of global studies, there is no dead zone near the Indian coast yet.
Yes, sir. Sir, there is a gap for Indian region. We can easily get information for US, Europe, European Union, as well as for Japan. But for Indian Ocean, there is some, for gap for this Gulf, nearer for Gulf of Kutch, Gulf of Oman. For total region of North Indian Ocean.
Okay.
Work has not been done, so actually there's a gap of. We need to find out exactly what is happening.
Okay. But my suggestion would be once we have mapping done, the next
Yes.
step would be taken it to see how the carbon cycle, ocean carbon cycle is changing.
Yes, sir.
How the
Yes.
NPP, its productivity
Yes.
over the
Yes.
time. Do we have any other comments from the?
Sir, I have one question.
Yeah.
Not question, query. What is the meaning of ocean desert? Because I have already worked in sea surface temperature. I have monitored sea surface temperature over Indian coastal area when I was working in Space Application Center. But this time this is confusing because I am not understand the meaning of oceanic desert.
Tatsat, please explain.
Yes, difference between dead zone and desert is uh, uh, dead zone may there are possibilities. Uh, I mean, as you said that some listed parameters like chlorophyll, SST. So when these parameters are changing multiple times for particular region, and the change, few dead zone can last for few hours to few days, as well as for few years. When this process is repetitive, and for the particular region or for the particular area, the productivity is less, then we can call that particular region as a ocean desert. We can check for some examples. In Gulf of
Okay.
Mexico, some regions are naturally, converted. Initially, they have formed as dead zone, and now there are some patches which are now converted into productive zones. So the zones which are not getting reversed, or they contains that productivity and a healthy marine life for a set of time period, we can declare them as ocean deserts.
It is directly linked with ENSO event.
Sorry, I didn't get it.
It is directly linked with ENSO event, El Nino Southern Oscillation. ENSO. Because
Sorry,
because in 1998, 2010, and 2016, in this period, high SST was measured.
Okay. Because
That
we
time,
have just started, yes, we have just started exploring this region with sort of sensors. So
okay.
currently, as of as I have said that we have listed down some sensors, and we are currently checking that research trends for
Okay.
phytoplankton as well as all these parameters. So once we finalize these sensors and all the things, then we'll continue with this thing. But thank you for the
Okay.
suggestion. Thank
Okay.
you.
Okay.
Thank you, Tatsat. Actually,
Thank you, sir.
a good area of development which you are starting to work on. Now I'd invite the next speaker, Alka Rani, on development of composite drought index and its comparison with Indian drought monitoring protocol for Karnataka. She is student. She is my PhD student at IRI. Alka, you may start, please, in 10 minutes.
Hello.
Yeah, your screen is visible.
Is it visible in presentation mode?
No,
Slideshow
it
mode?
is not visible in presentation. It is showing next slide also. Anyway, I think you can continue. Your slide is
Is it
visible.
visible now in presentation
It is
mode?
visible. Yeah, now it is okay.
Okay. Respected chairperson of the dais, co-chairperson, and all the fellow participants, a very good morning to all of you. I'm Alka Rani. I'm a PhD scholar in the division of agricultural physics, working under the guidance of Professor Vinay Saigal sir. And today I'm going to present my research work on the development of composite drought index and its comparison with Indian drought monitoring protocol for Karnataka. As we all know that agricultural drought is referred to a condition initiated by failure in the precipitation leading to decline in soil moisture and consequent crop failure without any reference to surface water resources. The success of any drought preparedness and mitigation measures depends upon the timely information on drought onset, progress, intensity, and areal extent. The accurate and timely monitoring and early warning of agricultural drought is important to reduce the adverse impact by adopting appropriate contingency measures. Several indices has been developed worldwide for the monitoring and early warning of agricultural drought. An ideal agricultural drought index should integrate various parameters like rainfall, temperature, evapotranspiration, vegetation health, etc. that impact crop growth and development during drought episodes into a single number. Therefore, in this study, a composite drought index using remote sensing datasets for agricultural drought assessment was developed and its performance was evaluated against the Indian drought monitoring protocol. So we have selected Karnataka as a study area because it has second highest drought prone area after Rajasthan, and the frequency of occurrence of drought is around 11 to 12 years out of 16 years. So for the development of composite drought index, we have mainly taken the three indices. First is standardized precipitation index, which is based on the precipitation or rainfall parameter. Second one is evaporative stress index, which represents evapotranspiration. And the last one is normalized difference vegetation index or NDVI anomaly, which represents the crop health. So for computation of SPI, the precipitation data was fitted to incomplete gamma probability distribution, and which was then transformed to normal distribution, and their z-score was taken as SPI. For the computation of evaporative stress index is the standardized anomalies in the ratio of actual to potential evapotranspiration generated with the thermal remote sensing based Alexis energy surface model, and the z score of NDVI was taken as NDVI anomaly. So these three indices were computed on monthly temporal scale and spatial resolution of 5 kilometer. The weightage of to these indices were assigned using the principal component analysis, and the first principal component was used because it accounts for the maximum variability. And after these indices were multiplied with their respective weightages, and their sum was taken to compute the composite drought index. And this composite drought index was computed only for Kharif season, means from the month from July to October. After the computation of CDI, the crop mask was applied, and from the land use land cover map of MODIS. And after that, we got the composite drought index for cropped area only, means agricultural area belonging to the Karnataka state. The severity classification was done using the methodology classification scheme given by Mackey et al. And After that, the district-wise mean of the CDI was computed, and the district-wise mean of yield data was derived from the ministry website, and the correlation between the crop yield data and CDI was computed for the validation of the CDI. Also, the performance of CDI was compared with the drought assessment using Indian Drought Monitoring Protocol, which is given in the Manual for Drought Management 2016, and also against the drought declared by the government. So, for drought assessment using Indian Drought Monitoring Protocol, there are two steps. First step is the mandatory indicators, which is based on precipitation, in which in the mandatory indicators is SPI and dry spell of the month of June and July are analyzed, and if there is drought trigger, then these are analyzed for the impact indicators, whether the drought has that mandatory indicators has impact on crops or not. So there are three impact indicators. First is deviation in crop area sown from the mean of recent 3 normal years. Second is NDVI deviation, and last one is vegetation condition index. So these three impact indicators are classified as normal, moderate, and severe, and the values of crop area sown, deviation in crop area sown, vegetation condition index, and NDVI deviation are given in this table. So after that, the agricultural drought severity classification is done. The drought is in severe category if two of the three selected impact indicators are in severe class and one is in moderate class. The drought is of moderate category if two of the selected three impact indicators are in moderate class, and it's drought, there is no drought or it's normal for all other cases. So for the, as we have computed the CDI using PCA, so we have assigned the weights using first principal component. So here you can see the frequency distribution of the weights assigned by PCA to these three indices, and the pixel wise weights, PCA weights were computed. So here we can see that the ESI has comparatively more weight, followed by NDVI anomaly, and SPI1, the weights assigned by SPI1 closely follows the normal distribution. So here you can see the correlation of SPI1 with yields of the Kharif crop. So district-wise yield of the Kharif crop. So here you can see that the SPI1 has more positive correlation with the during the month of July and August as compared to the July, August, and September as compared to the month of October. So here you can see the correlation of evaporative stress index with the yields of Kharif crop. The evaporative stress index has negative correlation with the Kharif crops yield. The more negative correlation is found during the month of July, August, and September. So here you can see the correlation of NDVI anomaly with Kharif crop yields. So here you can see that the NDVI anomaly has more positive correlation with most of the districts during the month of September and October as compared to the months of July and August. So here you can see the correlation of vegetation condition index with Kharif crop yields. So similar trend was found, like NDVI anomaly, similar trend was found for vegetation condition index also. More correlation was found during the month of September and October. So here you can see the correlation of our proposed composite drought index with Kharif crop yields. So they have more negative correlation with the Kharif crop yields, and during the month of September and October, the correlation was higher as compared to July and August. So here you can see the comparison of our proposed composite drought index with Indian Drought Monitoring Protocol and drought declared by the government. We have given here, as we know that the 2002 is known as the extreme drought year. So here you can see that our composite drought index was able to capture the drought event at pixel level, granular level, while the technology proposed by the government or by the manual is based on district level. So our index is proposed index is better as better as um, uh, it can depict the variation, spatial variation within a districts at village or block, village or taluka level, and within district variation can thus where the within district variation in severity can also be seen, which can be used for the successful implementation of the relief or preparedness or contingency measures. So here you can see that the CDI, the drought classification by CDI is closely related to the yield deviation map as compared to the drought declared by the government and the methodology proposed by the government. Here you can see that the drought declared the CDI for the normal year. So in the all the four parameters are showing are normal and they are not showing any indication of drought. This is the maps for the year 2015, which had moderate drought, which is referred to as moderate drought year. So here you can see that the CDI and the yield deviation maps are comparatively closely related. There are missing values, but this is due to the presence of other built up areas or non-agricultural lands, or due to the presence of clouds, which is the limitation of optical data. So but still we can see that the drought the government has declared drought for most of the districts, while the yield was not affected for them. So we can see that there are fallacy in the technique used by government, by the drought declared by government, which is based on anevari or passivari system. So yeah, but the pattern of drought and yield deviation yield deviation map are comparatively closely related.
Alka, please
So
conclude.
So coming to the conclusions, the CDI based remote sensing data was able to capture drought situation at granular level below the scale of a district or block, which would be helpful for policymakers to effectively implement relief or contingency measures. The CDI was able to capture drought situation as well as normal situation in the study region as reported from ground reports. The CDI related better to crop yield deviation at district level than that of the drought assessed by the standard methodology of Manual for Drought Management 2016 and the drought declared by government. The performance of CDI can be further improved by inclusion of other parameters like temperature, soil moisture, etc., and use of machine learning techniques for its computation. Thank you.
Yeah, thank you, Alka. You have already taken a bit more time. Do we have one question? Any important one question?
Alka, this comprehensive index can be used. Have you used it for horticultural crops? Were they there?
No, ma'am, it is only for the cereal crops, means food grain crops, means cereals, coarse cereals, oil seeds, and pulses.
Because nowadays many farmers are shifting to horticultural farming, so maybe it might be useful to them also, such a comprehensive index.
That can be analyzed. That can be a topic for future research. Thank you, ma'am,
Yeah.
for your suggestion.
Do we have another question or we shall move further because already we are now running short of time? Okay, thank you, Alka. Now, do we have next presenter, Sharmishta there?
I think no, sir.
She is not there, so I invite Dr. Bandopanja.
Am I visible and audible?
Okay, okay. I will.
But you were not there since the beginning, Sharmishta.
Actually, there was a bandwidth issue, and I have joined in the second presentation.
Okay. Yeah, so I invite, you are a student or a staff?
Sir, I'm a student. I'm a research scholar from MS University, Baroda.
Fine. Start your presentation. Her topic is spatio-temporal analysis of land surface temperature owing to NDVI, a case study for Vadodara district, Gujarat. 10 minutes for you. Now we are running short of time. Sharmishta, please share your presentation.
Share the screen and then share it again.
So, is it visible?
Yes, it is visible. Please start.
The topic is the spatial temporal analysis of land surface temperature owing to NDVI, a case study of Vadodara district, Gujarat. Land surface temperature is the radiative skin temperature of the land surface. It is affected by properties like vegetation cover, moisture content, surface roughness, soil radiation, etc. Land surface temperature is an important parameter related to surface energy and water balance at local and global scale. Accelerating rate of global urbanization onsets acceleration of land surface temperature. Hence, study of land surface temperature has become an imperative parameter globally for sustainable development. And the objectives are to investigate the spatio-temporal dynamics of vegetation and its impact on land surface temperature using satellite data. Secondly, to identify the correlation between land surface temperature with NDVI and SMI for the pre-monsoon period of 2001 and 2021 of Vadodara district.
Sharmishta, your slides are not moving. We are on the first slide.
So is it visible now?
It's visible,
It
but
is visible, but you click on directly on the slide. That time it will move.
So now is it moving?
No.
open in the people.
You can escape and reshare.
Share, then share it again.
So is it visible now?
Now we are seeing your computer screen.
Dharmishta, the oral presentation is there on the screen. Yeah, now it is there. Now just try clicking. Mohit says that you click on the screen, on the slide. Are you doing it?
Yes, ma'am.
चलिए आप बता दीजिए वैसे बिना स्लाइड के, because we are losing time.
And sir, for the study purpose, I have collected Lancet 7 for 2001 and Lancet 8 for 2021. Then by the help of thermal band, I have calculated LST for both the years, and then I have calculated NDVI, and from land surface temperature, I have calculated the soil moisture index, and finally I have calculated the relationship between the LST, NDVI and SMI, and these are the formula that I have used for calculating the LST, NDVI and SMI. Then my study area is Baroda district, which is located in the central part of the mainland of Gujarat. The climate over here is characterized by hot summer and dryness in non-rainy season. May is the hottest month, while January is the coldest month. The annual rainfall of the district is 475 mm. About 95% of the rain received during southwest monsoon season from June to September. The eastern hilly area is composed of hilly areas, whereas most of the land in the district is more or less plain. And then from the maps of 2001, it is observed that in the western portion, the LST is more, and NDVI is less, because there is much more fallow land is present over there. In the central portion, the LST is less, and because the NDVI is more over there owing to agricultural practice over the region. In the eastern zone, I have described that there is hill region, so there is bare and ridgy surface. So the LST is more over there, hence the NDVI is less over there. If I compare the map with the soil moisture of 2001, it is observed that wherever there is more vegetation, the soil moisture index is also more. And then when I go to see the maps of 2021, it is observed that LST has increased from 2001 to 2021. But I can see here the NDVI value has also increased from 2001 to 2021. Hence, it is seen that the soil moisture index has increased owing to more vegetation in 2001, and it is observed that there is positive correlation between soil moisture index and NDVI, and NDVI and LST is negatively correlated, and LST and soil moisture index is positively correlated. And hence, I would like to conclude that time and space are important parameter for the study of land surface temperature. Trees and vegetation lower surface and air temperature by providing shade and through evapotranspiration. May the study proves useful for urban planners to mitigate the acceleration of land surface temperature by reducing some of the negative impacts of urban development through urban planning. Thank you, sir. Thank you, ma'am.
Okay, thank you, Sarmishta. Just for your information, I hope you are only in the beginning of your research in this area.
Yes.
Actually, we have there is a lot of work on LST versus NDVI, and especially that has been used to map or develop drought indices like TVDI. So on the y-axis you keep the land surface temperature, and on the x-axis you keep the NDVI. So it is the basic background is that a greener NDVI would lead to a higher transpiration, leading to a lower land surface temperature. But many a time when over space you want to compare the same NDVI, but what is the LST for that? So that is important. So there is a lot of work which has been done where a combination of LST and NDVI are together used, especially to map drought indices, as well as to also make an estimate of evapotranspiration. So that is my, you please go through those studies because they have been published, well-researched areas. Okay. And
Thank you, sir.
do we have any other intervention? Any comments from anyone?
I think SAR data
Ma'am.
can also be useful for soil moisture, no, sir?
Yeah, but SAR actually is able to estimate only the top skin layers soil moisture. And LST and NDVI are more related to profile soil moisture.
I have one query.
Yes, please.
Ma'am, actually, one work already done on Vadodara district that is published in International Journal of Remote Sensing. And the title of that paper is, I think so, Special Temporal Variability of Land Surface Temperature and Vegetation Cover of Vadodara district of Gujarat using satellite data. So can I ask what is the new in this BOS study? In this study, sorry, current study.
So I have included 2001 data. I think it is the recent one because I think 2001 is not done for that. I'm not sure actually, but I try to include 2001 data.
Okay, if there are no more questions, we thank Sharmishta.
Thank you, sir. Thank you for your valuable comments.
Yeah, and please unshare your screen, and I'll invite our next speaker, Dr. Bandyopadhyay, who is going to make a presentation on assessment of impact of extreme weather conditions on parts of Indian Sundarban Biosphere Reserve using Google Earth Engine. Dr. Bandyopadhyay, please.
Yes, sir. Please, if from the organizer can share my slides, that will be better most probably. Or I can share. May I share, sir? I tried.
Okay,
You
sir.
are not able to share?
I shall try then.
Unshare
Okay,
your
sir,
Yeah.
I'm trying.
Stop, please unshare your screen.
Pardon?
Stop, please unshare your screen.
Sharmishta, you have to unshare your screen.
Please unshare your screen.
Mishta, please stop sharing.
Sharmishta, please. Otherwise, I cannot share.
So I have unshared my screen.
But
Maybe.
yours is coming only.
So next, please, from the organizer can. First, I thanks PRSC Ludhiana and for giving us the opportunity to share our work in this August platform, and also my sincere regards to Professor Sehgal and Professor Shukla for allowing me to present my work. But kindly, I am not seeing my presentation here. So should I share, sir?
Wait,
I
I'm
don't
not
know.
You,
How
you
should
may
I
share.
sharing.
You may share. It may go away.
May I share? Okay, sir, I'm trying. Item. Screen দিলাম, share দিলাম, share. So Mr. Bhumik will stop sharing on. You start sharing. Share.
Yeah, your screen has come.
Okay, sir.
Next, please. We are able to see.
Sir, but I can't. Okay, it is coming now.
Yeah.
So what I am presenting here today, it is our work assessment of the impact of extreme weather condition on parts of Indian Sundarban Biosphere Reserve using Google Earth Engine, right? It is not coming.
Yeah, it has changed.
Sir, it is the problem. I don't know what.
No, we are on introduction slide now.
Okay, sir. Okay, sir. Is it visible, sir?
Yeah, it is very well visible.
We all know that coastal environment and ecosystem is very sensitive, and
You have gone back to the first slide.
Okay.
it is not introduction, sir.
Just tell me.
Introduction was there, and now it has gone back to the first slide.
Just indicate me for the next slide. Okay.
But I don't know what is going on, sir. I have already changing my. Now it is introduction, sir. It is not showing.
No, it's not showing.
I'm not seeing.
Mohit, can you help?
Sir, I don't know what happened.
You can see this slide. Hello.
Hello.
Yes, sir.
Jatin Shankar, you can
Yes.
see this slide.
Yes, the first slide I am seeing, but how can I change? It is not changing, sir.
I will change. I
Sir,
will
click
change. I
on
will change
slides,
this.
then move, because when you are sharing that
I will change this, sir.
that time Cisco WebEx meeting icon is coming.
Yes, it is coming, but it is. I cannot change my slides, sir.
Sir, I am sharing your PPT. Just
Okay,
tell
then
me for
you
the
share
next
my
slide.
PPT. Second,
Yeah.
second,
I'm just playing your PPT. Just tell me for the next slide.
next, sir. Please, next.
Okay.
That will be the better. Yes. So, what, sir, now it is visible.
Yeah, it is visible.
Go first, don't worry. Coastal environment and ecosystem is very sensitive and fragile, which are basically affected by the, in case of Sundarban Biosphere Reserve and the area where I am working, by repetitive cyclonic attack as well as other natural hazard. Erosion and accretion are the major influencing factor for the shoreline shifting process. When shoreline shifted towards ocean, it is called positive change, and when it is shifted towards the land side, it is called negative change. The Sundarban mangrove forest are more vulnerable due to climate change event, consequent coastal flooding, anthropogenic activities, and also saltwater intrusion, decrease of soil fertility, loss of cultivated land are mainly caused by the several repetitive cyclone effect on the Bay of Bengal, that is the northeastern part of the study area. Flood inundation is increased due to global sea level rise and shoreline shifting behavior. At present, several tropical cyclones like Fani, Bulbul, Amphan, and Yas are observed in the northeastern part of the Bay of Bengal region. Second slide, please. Second. Sir, please share the second one. Yes, my study area, you can see, this is my study area which belongs to our Ganga Brahmaputra Meghna region, as from Indian as well as Bangladesh part. 4 blocks I took for my study. That is the Sagar Island, Kagdip, Namkhana, Pathor Pratima, and total area was around 2085 square kilometer. The area was situated between 80° 30 minutes east and 80° 57 minutes longitude, and between 21° 30 minutes north and 21° 01 minute north latitude. Next. Next, sir. Next slide, sir. Sir, next slide. Yes. Data used mainly Landsat 5 thematic mapper, 8 OLI TRS imagery are used for shoreline extraction with minimum cloud cover less than 10%, and the satellite image of 2021 is used for LULC classification. So in the Google Earth Engine cloud computing platform, 2 different temporal data were used for the flood inundation study, that is pre-cyclonic and post-cyclonic data of Amphan was derived from 20 April 2020 to 30 April 2020 and 18th May 2020 to 31st May 2020. For the yes, pre-cyclonic as post-cyclonic data was derived from 28th April 2021 to 30th April 2021 and 23rd May 2021 to 6th June 2021. The Landsat 5, the date and the path is written here, and Landsat 8, the date and path is written here. Next. Next, sir. This is the methodology. I am going to discuss this methodology, but it will take bit time. So next slide, sir. My result and discussion. Please, sir. Next. The deposition is found. Well, no. Previous one, sir. Previous one. So the deposition is found higher in the Lothian Island. You see, this is the Lothian Island. Here the deposition is maximum. Half Fish Island and Half Fish. This is the Half Fish Island and Sagar Island. Other part of the study area reflects the erosional activity due to the global sea level rise, neotectonic activities, tidal and wave action, and sediment transportation. At the time of erosion process, Lothian Island, you see the Lothian Island, this is the Lothian Island, erode around 18.92 square kilometer area, and the type of the accretion process, the island is accreted around 45.97 square kilometer. Ghoramara Island has lost, this is the Ghoramara Island, it is most vulnerable area, lost 39% densely habitated area, and Jambudweep has lost around 50% of the area during the last 30 years. Next slide, sir. Next slide. This is the, you see, flood inundation mapping of Amphan during the Amphan cyclone. that is the flooded area, blue color dot, what is showing on is the flooded area in Amphan, and flood inundation mapping of Yaas cyclone is in the blue color. So next. Next, sir, next. This is the LULC area due to super cyclone Amphan. Here the flooded area is showing in a black color, and all the area is showing according this index is showing here in case of Amphan, and in case of Yaas, the flooded area is showing in this area, the black color. You can check here that Amphan is most disastrous to this area rather than Yaas. Yaas is not affecting that much to this area. Next, sir. Next. So coastal vulnerability, mangrove forest degradation, saltwater intrusion, damage of cropland are mostly affected by the flood inundation. The following LULC classes are under inundated area. You can see the river vegetation in the Amphan period, blockwise affected area in Sagar Island, Namkhana, Kagdip, Pathor Pratima, and in case of Yaas, the same result is showing here. Mainly Sagar Island and Namkhana blocks were most affected by Amphan, and Sagar Island and Pathor Pratima blocks are most affected by Yaas cyclone. You can see in the figure 4 and 4b. Next slide, sir. Next. Next, sir. So this is the risk factor map, which is prepared by using the population data, shoreline change, and Amphan Yaas hazard area. The cyclonic risk factor is generating in the Moja map of the South 24 Pargana of West Bengal. The risk factor of the study area is calculated based on the two cyclonic flood inundation mapping. The risk factor is categorized in 5 classes like very high, high, medium, low, and very low. You can see this area is the most vulnerable, and deep green is less vulnerable area. Next, sir. Next, sir. So in conclusion, I can say global sea level rise is major threat to the coastal region because lowland areas are more prone to erosion. Cyclone, floods, and many other natural disasters affect the coastal region of the Sundarban, resulting in saltwater intrusion, increased soil salinity, decreased soil fertility, land degradation, shoreline change, and losses of crop production. On the other hand, sediment accretion has led to the formation of the new land. The study identified the flood inundated area due to Amphan and Yaas cyclone using Google Earth Engine cloud computing platform with the help of Sentinel-1 SAR data and the LULC classification using Sentinel-2 data. Total agricultural land was detected as 739.89 square kilometer in the year 1991, which was reduced to 661.94 square kilometer areas in 2021 due to various natural disasters as well as human activities. A huge amount of economic losses and life losses were noticed due to cyclone. Future research in the field of this area is very much needed, that is flood susceptibility mapping, cropland dynamics, shoreline change rate analysis, prediction, soil salinity measurement, agricultural development, sea level rise estimation, etc., for sustainable development of the area. Thank you, sir.
Thank you, Dr. Bandyopadhyay.
Yes, sir.
Do we have any questions?
Again, Sharmishta is coming in the slide, sir. I have seen Sharmishta. Mine has gone.
Yeah, we don't know what is happening.
Sir, no problem. Sir, another important thing, if you see the map of India, that part is basically funnel shaped. I am also related with your, sir, NDRM. I am also nodal officer of the Vidyasagar University for National Institute of Disaster Management. So we are planning to study in that area also. It is just like a funnel. It just shocked the cyclone sometimes. That Sundarban area, if you see the topography or the bathymetry of that sea area, you can see it always, whatever is the cyclone, it is always coming and it will hit there sometime.
Yeah, Dr. Bandyopadhyay, I have been to that area.
Yes, sir.
We have adopted a village also there for climate resilience.
And sir, another important information, my student who is working in this area, he is also affected by this Amphan cyclone.
Okay.
He was there from that village.
Very good work which has been presented, and making use of the remote sensing data, both optical and microwave.
Yes.
Do we have any other comments?
All I wanted to say was that the mangroves, the vegetation, which is the best over there, I think that can help to save the land from this cyclonic effects, no?
Yes, madam. You are very right. But problem is that indiscriminately people destroying the mangrove starting from the British era. Their policy was to clear the mangrove, and you can imagine that small area is the habitation of 22 lakhs of people, unimaginable population density, very high population density. So they are trying to live their livelihood through the forest area, fishing.
It is a very ecologically fragile area.
Fragile area, sir. Absolutely, sir.
Mangroves. I had stayed many nights at Khali. I don't know.
Oh, sir. Oh, great, sir. This time, if you come, please inform me. I will also join with you, sir.
It
Sure,
is my dream to visit Sundarbans.
Oh, thank you, madam. Please come again. After COVID, now gradually it is started taking the tourism also another business. So they are also destroying in some way. But
But that particular delta region is, from agriculture point of view, is very peculiar. That in the monsoon everywhere there is water, and after monsoon you don't have even drinking water.
Yes, sir. Very right. You are very right. Sir, most of the water is supplied from Calcutta itself in Goshaba, that is most affected. You can get the drinking water is coming by from the Kolkata area. They are getting drinking water from Kolkata. And I'm sorry to say that, sir, British have done a very, I don't know why they have done this, why they put people there in this hazardous zone.
Anyway, thank you, Dr. Bandyopadhyay, for initiating such a scintillating discussion, and it is of important good work. Congratulations. Now may I invite our last presenter. We are already past our time, Rohit Bisht.
Thank you, sir.
Who is going to make a presentation on a case study on water quality parameters of upstream portion of Rispana River, Dehradun. Rohit?
Yes, sir.
Please share your presentation.
Is it visible, sir?
Yes, it is very well visible.
Good afternoon, everyone, panel members and delegates. I am Rohit Best, student of DIT University, BTech Civil Engineering final year, and I represent my group's work here. The title of our work is a case study on water quality parameters of upstream portion of Rispana River, Dehradun. It is a well-known fact that rivers in India face tremendous pollution, and yes, large rivers do get the attention of the government and other bodies, but small rivers or drainage rivers go unnoticed. One such river is Rispana River that flows in the central region of Dehradun and is formed by the confluence of two streams that are Nalapani Ki Rao and Rispana Ki Rao. They merge at the given coordinates, and you can see the confluence of both the stream in the given image. So the current state of the river is very poor, and it faces tremendous pollution due to anthropogenic activities. And recent media reports do cover the state of Suswa River, which is formed by the confluence of Rispana River and Bindal Rao. And this Suswa River carries the pollutants into the Holy Ganga River. But such studies seem to be missing for the upstream portion of Rispana Rao, and therefore our studies focused on the same. So for analyzing the water samples of Rispana Rao, we chose 6 sites. And the coordinates have been mentioned in the given table, and the map represents the position of the respective points. Sampling method adopted was composite as per IS 3025 Part 1 1987, and sampling was carried out in 3 phases, that is pre-monsoon, monsoon, and post-monsoon, as per the given dates. The photos present sample collection. So the pre-monsoon work includes collection of water in the extreme upstream portion of Rispana Rao. In the pre-monsoon season, most of the river runs dry, and there is water in the river only up to point P3, beyond which it dries up or most of it seeps into the ground. in the monsoon river, the flow rate increases and river becomes active, and there can be seen quite increased flow in the downstream region also. And the same goes for the post monsoon season, but with a lesser rate of flow. The given slide represents our test results, and as per the results, it can be seen that in the site S2, there is found increased chloride content and reduced dissolved oxygen, which is due to discharge of domestic sewage directly into the river. And coming to the conclusion, our study finds out that the extreme upstream portion of the river is still untouched from the pollutants, as it is away from civilization, and contamination of the river starts as the river starts crossing the human settlements. And this can be seen in the slum area of Hard Bangla, which is the site S2, where domestic sewage from the slum gets discharged directly into the river, and the site has also become a dumping ground for solid waste. These are the conclusion. And coming to the future aspects of the project, it is never too late to realize one's mistakes and make amends, and the rejuvenation of the river therefore can be carried only by combined efforts of government and people. And for this, priorities need to be given to waste management facilities, and sanitation facilities near the slum area need to be developed. Also, we observed illegal encroachment and sand extraction, which causes weakening of the slope of the riverbed, and such activities should be strictly monitored by the government, and awareness programs should be carried out. With that, I would like to conclude the presentation. Thank you.
Thank you, Rohit. A good start, a good presentation. The only thing is we were looking for some remote sensing data, but you are yet to include it in. So do you have any plans to include also some quality parameters derived from remote sensing?
Not as of now, sir. But we can look into.
I feel you should, being a BTech student and still you may be doing MTech or PhD,
Yes,
you may explore this possibility, and there are a lot of information which you can derive from remote sensing also, which can directly as well as indirectly give you some parameters on water quality.
Yes, sir. We'll include it in the next project in the next semester.
Yeah,
Thank you.
because that is one area where you can do a lot of data crunching, data mining also. Do we have any other comments on this presentation? Any other?
And yes, Rohit, when you mention hardness and chloride separately, I believe
Yes.
that chloride is also part of hardness only, no? Chloride also contributes to hardness. And when you write hardness, does it
Yes.
mean some positive ions imparting the hardness, or what?
Calcium and magnesium salts, basically. But chloride is tested separately, as it it indicates pollution by domestic sewage. Therefore, it is tested separately.
Rohit, I also have one more suggestion, that
Yes,
even with your current work, can you use the DEM and other terrain parameters to actually cite where they should put in the water treatment plants, sewage treatment plants, so that a lot of pollutants don't directly go into the river. So that is also one area which you can think of, where more geomatics comes into play than remote sensing.
Yes.
Okay, thank you. We have come to the end of all the presentations, and I thank each one of the presenters to be available and making the presentation more or less within the time. Actually, we had basically 1, 2, 3 presentations on impacts. One was on using remote sensing Google Earth Engine from Mohit, which would talk about inundation mapping.
Stop sharing the screen,
Another
please.
was on
With upper side.
using in Sundarban areas, and third one was basically the quality parameters, which is just quantifying the problem where it is starting out and what is the extent during pre-monsoon and post-monsoon. Then we have a new area which has been, I was not aware of, a newer area related to ocean remote sensing, and that is monitoring the dead zones and deserts. Alka has actually dwelt on developing a newer composite drought index, which may work, as she has shown that it has worked better than the current protocol which is being followed. And I was the one of the main author of that main protocol. So she's negating whatever we had thought of. But anyway, science develops in that direction. You think of, you implement it, and then you put more science to improve on that. And of course, Sharmishta has presented how land temperature varies for different NDVI classes present, where the science is more or less clear, but she can still work to develop indices which may better capture the conditions or water stress of the vegetation. And of course, overall, mostly we have talked of disaster management, and I have not seen any presentation in this which relates to climate resilience or climate change. With that, I would request my co-chair also to give her comments if she has anything to add to that.
I think I pretty much go with that. And as far as this new topic of oceanic dead zones is concerned, yes, it concerns with disaster, but also the climate resilience of the ocean ecosystems. That is what, because we want to find out the spread of such zones, if at all they are there, and so that we come to know the resilience if they are not there.
Yeah, thank you, Dr. Alpana. I'll take my word back and say that we have one on climate resilience related study and others are mostly on disaster management.
Thank you to all presenters, chairs and co-chair of this session. And now it's time to present memento to our chair and co-chair. I request to co-chair of this session, Professor Alpana M. Shukla, to present a memento of appreciation to our chair, Professor V.K. Sagar. Sorry, yes. Now I again request chair of this session, Professor V.K. Sagal, to present a token of appreciation to our co-chair, Professor Alpana M. Shukla.
Madam, this is an appreciation for your efforts.
Thank you, sir.
Virtual appreciation, sir.
Yeah, at least we are virtually present, but one-to-one. So at least we can say that.
Thank you. Yes,
sir. You will receive this from through speed post or register post.
Okay, good.
Thank the organizers for this kind of appreciation. Thank you.
Thank you, ma'am.
So if we don't have anything else, I thank the organizers. I thank my co-chair for helping out to conduct this session. And also, I again thank the organizers for giving us the opportunity to be part of this session, especially listening to the students' work, which give us idea that where all the new things are going into the direction. And of course, to know about Dr. Bandyopadhyay from Vidyasagar University. So that was also a pleasure, sir. Thank you all. Thank you. I give it back to the organizers.
Thank you, sir.
So we call it off the day.
Yes, sir. Yes, sir. Yes.
Mohit, how we are supposed to send you this? Should we scan the result and send you?
Which, ma'am?
The evaluation sheet.
Ma'am, yes, ma'am. You send it through email.
Madam, what we will do, we can discuss ourselves because ultimately we have to sign both.
Yes, sir. Yes, sir. Shall I call you later or what?
Yeah.
Okay.
Whatever you can fill up, I will also fill up and then we will decide on.
Yes, sir. Yes, sir. Definitely.
Okay.
Thank you, sir. Thank you, ma'am.
Thank you all. Have a good day.
Yeah. Good day. Thanks.
Thank you. Yes.
Am I audible? Good afternoon, all. I welcome you. Just a minute. Hello. Yes, good afternoon, all. I welcome you all in this session of disaster management and climate resilience, T6B. There are 6 presenters in this session, and Dr. Shakil Ahmad Romshu, he is going to chair this session, while co-chair is Dr. D.R. Rajak. And I hope all the participants have joined the session. May I call one by one? Soumya, have you joined the session? Soumya, have you joined the session? Farheen Kazi,
Soumya is not here.
Yes, ma'am.
are you there?
Yes, ma'am.
Farheen Kazi,
Yes, ma'am.
please unmute yourself and respond. Farheen Kazi, are you there?
Yes, ma'am.
Okay. And what about Soumya?
She is not here.
She has not joined?
Yes, ma'am, not.
Okay. Then Abida Bashir?
Yes, ma'am.
Okay. Then what about Midhat Fayaz?
Yes, ma'am.
Then Jasia Bashir?
Yes, ma'am.
Are you there? Hina Shafi?
Yes, ma'am. Ma'am.
Okay.
All are here.
So
except
Soumya is
Hina.
going to join us or not? I don't know. She will. She has got first presentation.
We'll start at the Farheen.
Okay. First of all, I will introduce you with our chair of the session, Dr. Shakil Ahmad Romshu. He is Vice Chancellor of Islamic University of Science and Technology and has a multidisciplinary academic background. He has obtained PhD in water resources.
Hello, ma'am, sorry to interrupt you.
Yeah.
Just to make sure whether Professor Romsu has joined or not.
Sir, just a minute. I think he is calling.
Okay.
Hello. Okay. Yes, your presence was required in Hall D, sir, because I have just started the question. I have just started the session and we are waiting for you. But you are not going to connect. Sir, I asked the organizers to help you. I just call them. Okay, okay. Okay, okay. I just call them, sir. Okay. Just wait, sir. I'm just calling them. Okay. We have to wait for a minute for Dr. Romshu. He's trying to. Hello. हाँ जी सर वो डॉक्टर रोमशो ਜਿਹੜੇ ਚੇਅਰ ਕਰ ਰਹੇ ਨਾ ਸੈਸ਼ਨ को उनका फोन था कि वो ज्वाइन नहीं कर पा रहे उन्होंने वो कहते मैं ज्वाइन कर रहा हूँ, कनेक्टिंग शो कर रहा है, बट आई एम नॉट एबल टू ज्वाइन. कैन यू चेक प्लीज? Okay. Okay. He's saying that I am able to join Hall A but not Hall D. But he is required in Hall D. No? Yes. If you can help him. Okay. ठीक है. I just shared your number to him. Okay. Sorry for interruption. We have to wait for a minute for Dr. Romshu. Please. Hello. Sir. Hello. Sir, 94190. I'm telling you the number 94190. 4190 10924. You, Dr. Romshu is there. You just ask, help him. Okay. Hello. 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 Hello.
हेलो मैम, मीनाक्षी मैम, संकल्प.
Yes, I think
जी मैम.
Dr. has joined. Hello. नहीं, मुझे I think he is visible on the screen. I think he has joined. I will just confirm it. Okay. Okay. Hello. I think Dr. Romshu is there in the session. Sir, are you in the session? Please unmute yourself, sir.
He's in the session.
Hello.
Sir's network is not stable.
Yes.
Yeah.
Dr. Romshu, I think you are in the session. Should I start the session now?
Yeah, are you
Start.
able to hear me?
Yes,
Yes,
we are
we
able
are
to
able
hear
to
you.
hear you.
Yes, good
Yes.
afternoon, Ramsu sir.
Good afternoon,
You are
sir.
well audible.
Yeah.
So I think I should start the session now.
Yes, please. Yes, ma'am.
Okay, thank
My
you. Now,
yeah.
hello. Now I will
Yes, please.
To the chair of the session, Dr. Shakil Ahmed Romshu. He is Vice Chancellor of Islamic University of Science and Technology, has a multidisciplinary academic background, and has obtained PhD in Water Resources Engineering from the University of Tokyo, Japan, and MS in Remote Sensing GIS from the Asian Institute of Technology, Bangkok. With more than 33 years academic experience, he has worked in the past as a scientist at the Japan Aerospace Exploration Agency, Tokyo, and fellow at the Tata Energy and Research Institute, New Delhi. He was still recently Dean for Research at the University of Kashmir and has headed several departments at the university during last 17 years. Till date, he has guided 22 PhD and MPhil students and published more than 235 papers in journals and book chapters with a total citation score of nearly 3,370 and H index of 32 and cumulative impact factor of score nearly 290. Romshu sir is engaged in research on hydrology and climate change with the geographical focus on Himalaya. Professor Romshu is a member of score of policy making committees and working groups on environment, water, climate change, and disasters at local, national, and international level. He is elected Fellow Indian Academy of Sciences, Fellow Indian Society of Remote Sensing, and Fellow Indian Society of Geomatics, and has won more than a dozen of national and international awards for his academic achievements. And notable among these were Satish Dhawan Award from IRS in 2019 and National Geoscience Award conferred by President of India in 2013, ISC President's Appreciation Medal for Promotion of Geomatics in India in 2015, and many more prizes like this. And got Appreciation Medal of ISC conferred by Shri Narendra Modi, CM of Gujarat in 2008, and KU Best Performer of the Institute Award conferred by Governor of JK in 2010. It was all about our chair of the session, Professor Shakil Ahmed Romshu. And now I introduce here to the co-chair of this session, Dr. D. Ram Rajak. He is Scientist Engineer SG and heading Geoscience Division in Space Applications Center, ISRO, Ahmedabad. And he's bachelor's in civil engineering, master's in remote sensing, and PhD in operational management. A scientist at Space Applications Center, Indian Space Research Organization, Ahmedabad, since 1991. Currently, his primary area of research is geoscience, studies with satellite-based Earth observation data, and participated in 33rd Indian Expedition of Antarctica. In Arctic expedition in March, April 2019 and led two Himalayan expeditions and Chilpa glaciers. Earlier coordinated a national scale program forecasting agriculture output using space, agrometeorology, and land-based observations, supported in technical techniques development for operationalization of fossil, which was transferred to Ministry of Agriculture. Successfully completed many projects on remote sensing applications as project and principal investigator at SAC, ISRO since 1991. There are more than 50 publications in the form of papers in journals and symposium, along with scientific articles, books, and athletes, etc. Organized an international and a national symposium as organizing secretary and awards and recognitions, including University Gold Medal from IIT Roorkee in 1991, ISRO Team Award in 2007, GIS Development Geospatial Excellence Award in 2009, Best Paper Presentation in 2008, and Best Paper Award in 2012 in ISE ISRS National Symposium 2018. It was all about our chair and co-chair of the session. And now I'm going to start this session. And our first presentation, there are 6 presentations in this session. And the first presentation is from Soumya. Is she there and going to present her paper? Dr. Soumya is there. If she is not there, then I will ask Fahim Kazi to make the presentation and share the presentation. And also mention about your category. Are you in general or student category? And you will be given 8 minutes for your presentation and 2 minutes for the discussion. Please share your slides, Farheen Kazi. Start your presentation. Farheen Kazi.
Yes, ma'am.
Please start your presentation.
Yes, your slides is visible. Please start.
Am I audible?
Start. Yes, you are audible. You just start your presentation.
Okay, ma'am. Respected chair, co-chair, and all the members of ISG, a very good afternoon to all of you. This is Farheen Kazi from the Geomatics University of Kashmir. I am here to present my paper over the topic assessing the soil erosion changes in Greater Himalaya watershed using the ICONA model. This is the outline of my presentation. I will give a brief introduction about the soil erosion. Further, I will discuss the study area. Then I will be discussing my objectives and data sets, and then methodology, and finally we'll discuss the results and conclusion. Coming to the introduction, soil erosion is the displacement of the upper layer of the soil. It is a form of the soil degradation. Soils of this cold air region of Ladakh are quite distinct from those of the other regions due to the difference in climate, topography, vegetation, and rocks. Due to the slopy and the rugged topography of the region, the extent of the erosion varies from moderate to very severe. So the geoinformatics technology, it provides a platform with advanced capabilities and potentials of the real-time hazard detection with the spatio-temporal distribution and the soil erosion hazard predictions. So the geoinformatics, it can be applied for continuous monitoring and evaluation of the soil erosion hazard to detect reduction and prevention the damage. Applications of this remote sensing represents a possible solution in the assessment of soil degradation by erosion at the regional and the global scale. This is the map showing the location of the study area. That's the Kargil district. Kargil district is a district in the Union Territory of the Ladakh in the northern India. It is the second largest town in Ladakh after Leh, and it is situated along the banks of the Suru River. It spans the entire length of Ladakh in the north-south direction, with the Jammu and Kashmir to the west, Leh district to the east, and the Pakistan administrative region to the Gilgit-Baltistan and to the north, and Himachal Pradesh to the south. This is the objective of my study, to assess the risk of erosion and to identify the vulnerable areas to soil erosion in the Greater Himalaya region and their change between the 1992 to 2020 using the ICONA model. These are the data sets that I have used. I have used the Landsat TM and Landsat OLI. For the year 1992 and 2020, I have used the high resolution data, Google Earth, digital geological map, digital elevation model, SRTM DAM, and the ICONA model. Coming to the methodology to estimate the degree of erosion risk in Kargil district, ICONA model was used. First of all, slope map was generated from the dam in ArcGIS. Then lithophysicists map was prepared by analyzing the geological map and geological formation. With the help of the slope and the lithophysicists map, erodibility map was generated. At the same time, land use land curve maps were generated from the Landsat TM and Landsat OLI of the 2 years. with the help of the supervision classification, and NDVI map was also generated. Then the soil protection map was created by overlapping the NDVI map and the land use land cover map using the ArcGIS. Then finally, the erosion risk map of the year 1992 and 2020 were generated by combining the soil erodibility and the soil protection map. Coming to the results, the first one is the slope map. Slope layer of the study area was generated from the dam data in ArcGIS and classified into the 5 groups. According to the slope map, 30% of the study area contains 32 to 48 degree slope classes. That is, the majority of the study area has steep slope. The moderate slope classes also comprise the second tier, equivalent to the 25% of the study area, while the limited surface area of the Kargil district is extremely steep. Second one is the lithofaces map. In order to prepare the lithofaces map, I used the geological map, which I georeferenced and then digitized the same. Geological map was an analyzer, and the geological formation were classified into the 5 groups according to the resistance to weathering. That's a low, very low, medium, high, and very high. A map of the lithofaces of the Kargil district shows that the much of the study area is 46%. It's composed of the Lamayo limestone Kargil formation. In this formation, these formations are of the low resistance, strongly weathered, and low resistance to the weathering. Only 2% is composed of the shallow ophiolite milling that are vulnerable to the erosion processes. 7% belongs to the Ladakh plutonic complex, which are resistant to the weathering. And then the third map, that's the slope map and the lithofaces layer, they were overlapped to produce the erodibility map. In the erodibility map, it shows that the 42% of the study area is in the class of the moderate erosivity. Also, 37% is highly erodible. Only 17% is low erodible. For generating the land use land cover map, I used the satellite image Landsat TM with 30-meter resolution of the year 1992, in which the training samples for each class were taken, and the supervisory classification was done, and 7 land use land cover were determined. So according to the classification results, Wasteland Barren has the largest area coverage. It shows the highest percentage of the total land use land cover, that is 65%. Whereas the built up, it occupies the least area, that is the minimum land use land cover is built up with 0.01%. For generating the NDVI map, NDVI was performed and applied to the Landsat image and classified into the 3 groups. In NDVI calculation, NIR and the red bands were used. According to the NDVI classification, according to the NDVI calculation, values were found to be between -0.64 to 0.69 in the study area. According to the results, the highest percentage of vegetation, that is the 50%, have moderate vegetation cover. Only 6% have high vegetation cover, and 44% have low vegetation cover. Then is the soil protection map. The soil protection map of the year 1992 shows that 89% of the study area have low protection. Means the majority of the study area is in the poor conservation conditions. 10% of the area has moderate protection cover, and only 10% is that a significant portion of the area is in the good conservation conditions. Now coming to the results of the year 2020, as the slope and the lithofaces map being the same, I have analyzed the land use land cover of the year 2020. I have found that the wasteland barren has largest area coverage, showing the highest percentage of the total land use land cover, that is 81%. Whereas the built up occupy the least area, that is the minimum land use is built up. Means the wasteland barren has increased from 1992 to 2020. And built up has also increased. So according to the NDVI map of the year 2020, the highest percentage of the vegetation, according to the NDVI map of the year 2020, the highest percentage of vegetation, that is 48%, have moderate vegetation cover, only 22% have high vegetation cover, and 30% have low vegetation cover. Then coming to the soil protection map, the soil protection map of the year 2020 shows that 85% of the study area have low protection. However, the 11% of the study area have moderate protection conditions, and only 4%, that is a significant portion of the study area, is in the good conservation conditions. These are the 2 maps showing the erosion risk of the year 1992 and 2020. The erosion risk map of the year 1992 shows that the middle class of erosion risk accounted for the largest percentage, that is the 58% of the area. On the other hand, the high erosion risk class comprises the significant portion, 38% of the area. Therefore, a significant portion of the area is at the moderate to the high erosion risk, and only 4% of the area's surface constitutes a low erosion risk class. Whereas the erosion risk map of the year 2020 shows that the middle class of the erosion risk accounted for the largest percentage, that is the 54% of the area. On the other hand, the high erosion risk class comprises the significant portion, that is the 40% of the area, and therefore a significant portion of the area is at the moderate to the high erosion risk class. And only
Your
6% of the
your
area.
time. Please conclude the paper. Please conclude the things.
And only 6% of the area is constituted low erosion risk class. Coming to the conclusion, the erosion risk map of the year 1992 shows that the moderate erosion occupies the highest percentage of the erosion risk, 58, and the high erosion risk class comprises significant portion, and that is 38%, and only 4% of the area is under the low erosion class. Whereas the erosion risk map of the year 2020 showed that the moderate erosion class occupies an area that is 54%, the high erosion risk class occupies a significant portion, that is 40%, and only 6% of the area is under the low erosion risk class. So the results it suggested that from 1992 to 2020, the moderate erosion risk class has increased in the region. That is the area under the severe and the low erosion classes have increased. The reason can be like due to the increased plantation and agricultural activities during these years, roads, infrastructural activities that have increased in the region. It can be the cause of increase in the low and the high erosion classes. So the ICONA model, it provides a reliable framework for the identification of the potential erosion-prone areas in the region, and the information generated in this research, it can be vital for the developing strategies for the mitigation of the land degradation, so that the vulnerable areas are identified and are better utilized for the socio-economic development of the study area. Thank you.
Paper is open for questions. Any questions, please?
Madam, thank you, Farheen. It was very, it was a very good study, and your presentation is excellent. Just for my clarification, can you just tell me why you have used ICONA model? Because there are so many other models. So can you tell me just in short, what are the specific advantage of ICONA model over other models?
Please unshare your screen.
Yes, actually, this model, this icon model, actually it was developed by the Spanish Society of the Conservation of the Nature, and it is one of the simplest and most flexible qualitative methods for assessing and mapping the soil erosion risk.
Okay, thank you, Farheen.
Thank you.
Any more questions? If there are not any more questions, I will ask Abida Bashir
Unshare your screen.
to present her paper.
Hello, Farheen, please unshare your screen.
Hello,
Ma'am.
Abida Bashir.
Yes, ma'am.
Please share your presentation and start the presentation. And time is 8 minutes. Please don't go beyond that.
Is visible?
Hello, you're not very clearly audible.
Hello, ma'am.
Be loud. You're not clearly audible.
Now it's visible.
Just start.
Okay.
Because clock has started.
Respected chair and co-chair and my fellow members, a very good afternoon to all of you. I am Abida Bashir, the student of MSc Geoinformatics from the University of Kashmir. Today I am here to present my paper, that is the assessing soil erosion change in the greater Himalayan region under changing land use land cover.
Please try to be loud, Abida Bashir.
Okay, ma'am. First of all, I will give you a brief introduction about my study, as soil erosion is a serious problem governed by natural as well as anthropogenic factors, which results in the loss of fertility, productivity, and quality of soil. There are various factors which affect the disasters and which can trigger the erosion, such as topography, climate, and other land use land cover patterns. The remote sensing and geographical information system techniques have made it very much possible to measure various biophysical parameters like vegetation cover, soil texture, topography, and other meteorological parameters like temperature, precipitation, and humidity at different spatial scales have resolved to these things.
The study area of the Kargil district, which lies the Ladakh region of Jammu and Kashmir state at an altitudinal level of 8,000 feet to 18,000 feet above the sea level, and it lies in the eastern longitude and latitude of these extents. The Kargil district, has a vast geographical area of 17,206 square kilometer approximately. It comprises of 7 tehsils, that is Chektan, Dras, Kargil, Sanku, Shirgol, Tessur, and Zanskar. The main objective of my study is the estimation of soil erosion under changing land use and land cover in Kargil district. Using a universal soil loss equation model, and the data sets which I used in my study are DEM, and that is SRTM DEM 30-meter spatial resolution, Landsat TM, and Landsat OLI from 1992 to 2020 respectively. Meteorological data from TRIM, that is Tropical Rainfall Measuring Mission, and the soil map from Harmonized World Soil Data. The methodology of my study is below. First of all, we use DEM, from which we generate LS factor, the topographic factor. Soil map gives us the erodibility factor, and then from land use land cover gives us the cropping factor and conservation practice factor. And meteorological data gives us the rainfall erosivity factor. Then combine these 4 data sets and can generate the universal soil loss equation. Then we use this universal soil loss model. After that, it gives us information about soil loss due to erosion from the year 1992 to 2020. These are the results of my study from 1992, having different factors which I have calculated using universal soil loss equation. Topographical factor of the area, I have used the SRTM DEM of 30-meter resolution, from which I firstly calculated the slope for the area, and then from the slope I concluded the LS factor. The topographic factor represents a combined effect of length and steepness of the slope. The map shows LS factor. You can see the high value red, that is 1 to 9.056, shows more steepness, and low value blue, that is 0, shows less steepness. Erodibility factor, I have used the Harmonized World Soil Database, from which I firstly concluded the various factors of soil which are found in the world, from which I concluded that the study, my area of interest, I have only 2 types of soil, that is loamy and the clay, which concluded that the erodibility factor for the area, which gives us high value of 0.67%, while the lowest value for the erodibility factor is the 0.49%. The rainfall erosivity factor of the Kargil district, I have used the rainfall data from the TRIM data of the precipitation for analyzing the rainfall erosivity of the area. The R factor values were estimated ranging from 84.082 to 893.572 megajoule millimeter. That is you can see the value, that is 84.082 represents the less amount of rainfall, while as this value 893.572 represents the more amount of rainfall. For generating the land use land cover map of the year 1992, I have used the satellite image Landsat TM with 30-meter resolution, in which their training samples for each classification and supervised classification was done, and 7 land use land cover classes were determined. The distribution of land use land cover type is present in the table. From land use land cover map, I have generated the conservation factor and the cropping factor. These are the results of 2020. The topographic factor, the soil erodibility factor, and the rainfall erosivity factor are same from 1992, but changing the land use land cover pattern, due to which some changes can be seen. For generating the land use land cover map of the year 2020, I have used the satellite image Landsat OLI with 30-meter resolution, in which their training samples for each classification and supervised classification was done, and 7 land use land cover class were determined. The distribution of land use land cover type is presented in the table. From land use land cover type, from land use land cover map, I have also generated the conservation practice factor and the cropping factor. The overall result shows that from 1992 to 2020, the high class changes from 49 to 57% area, from moderate goes decreases, from 47.53 to 37%, and then low area from soil has increased from 1992 to 2020. In 1992, 49% of the area was under high erosion risk, 47%, 47.53% area was under moderate erosion risk, and low erosion occupies 3.44%. While the year 2020, the area under high erosion risk was increased 57%. Moderate erosion decreases to 37%, and low erosion was 5.19%. The result suggests that with moderate erosion have decreases from 1992, while the area with a high and low erosion has increased from the year 1992. Thank you.
Any questions regarding the paper?
Yeah, Avida, thank you for a nice presentation. Just one or two small queries. You are telling that the moderate soil erosion had decreased from 1992. Can you just tell me what can be the reason? Probable reason?
Sir, infrastructural activities like roads, buildings have increased during these years.
Okay, so moderate has decreased, but other classes they have increased. Okay, and because you know that Farheen has also done same kind of a study in Kargil district and the same time period. So have you compared your result with the results what Farheen got? Abida? Am I audible?
Sir, repeat question.
Yeah, I was asking because you know two studies are done in Kargil district over the same time period and different approaches. So whether you have compared these two kind of results.
More or less or similar results.
More or less. But can you tell me which method is better in future if someone want to do, whether one should go for Icona model or the methodology which you have adopted?
I think Icona model.
Okay. Okay. Thank you, Avida.
Sir.
Thank you, sir. Sir, if there are not any more discussions or questions, should I proceed for the next presentation? The
Yes,
next presenter is Midhat Fayaz. Time is only 8 minutes.
Good afternoon, everyone. I am Midhat Fayaz, a research scholar from Department of Geomatics, University of Kashmir, here to give a presentation on the topic Earthquake Structural Vulnerability Assessment based on the AHP and the TOPSIS approach, a case study of Srinagar City, Jammu and Kashmir. So, is slide moving?
No, it's not moving. Yes.
Okay. As we know, earthquakes shake the ground beneath the feet and cause buildings, roads, homes, and all other fixtures to crumble. Earthquakes, being more destructive disasters, cause enormous damage to human settlements, especially to densely populated urban areas. And the increased trend of seismicity over the last few years observed in the Himalayas has become a matter of concern for the safety of life and infrastructure in the region. On the top left side of the slide is the map showing the motion of Indian plate that is colliding with the Eurasian plate and is continuously getting subducted under the Eurasian plate. As a consequence of this collision, Himalayas are formed. Due to this collision, earthquakes are continuously occurring in this area. And this is the map showing the location and distribution of earthquakes that has occurred in the past 1 century. So Kashmir Valley located in the northwestern Himalayan belt represents one of the most seismically active and vulnerable zone of the Indian seismic zonation map. The valley has experienced several great earthquakes in the past, and the region between the rupture zones of these great earthquakes are recognized as seismic gaps that are interpreted to have accumulated potential self for generating future great earthquakes. So it is therefore apparent that the earthquake catastrophes are waiting to happen in near future unless preventive measures are taken. So the present study aims at carrying the seismic vulnerability assessment of the Srinagar ST to minimize both the social and the economic losses. So this is the slide showing the study area, that is the Srinagar ST of Jammu and Kashmir. The total area of the ST is 245 square kilometers and is divided into 75 administrative wards. Now coming to the methodology section, in this study, 6 most influential vulnerability parameters are selected for assessment of earthquake vulnerability based on the literature review, this expert opinion, and by analyzing available data. The selected parameters are building construction type, shape of the building, building density, and pounding possibility, width of roads, and building height as well. The parameters are generated in GIS environment and also collected during the field surveys. After the generation of these parameters, the analytical hierarchical model, that is the AHP model, was used to weight and rank the factors on the scale from 0 to 1, in which 1 signifies 2 parameters are equally important, and 9 indicates that one parameter is extremely important than another. Analytical hierarchical process uses the opinions of experts to weight vulnerability parameters and subparameters also, and as a result, transparency and consideration of local special conditions of the study area are ensured that global indices cannot consider. So in this study, we have generated the comparison matrix of 6 seismic vulnerability factors based on 2 expert opinions. Then the geometric mean of 2 expert opinions is calculated to aggregate the opinions into one matrix. After the generation of this binary comparison matrix, the unnormalized and the normalized values are calculated using this equation, and then the consistency is measured using the consistency index and the consistency ratio. And if this consistency ratio is below less than 0.1, then the pairwise comparison matrix is consistent, and if it exceeds the value of 0.1 pair, then the pairwise comparison matrix must be iterated between the indicators and the sub-indicators until it shows a good consistency. After using this AHP model, we have used another model, that is the this technique for order preference by similarity to ideal solutions, that is the TOPSIS. It's the multi-criteria decision making method, and it is used to choose alternatives based on distance from positive and negative ideal points. The TOPSIS model works on the concept that the shortest distance from the ideal solution and the farthest from the negative ideal solution. Here also construction of the normalized and the weighted normalized decision matrix is done, and then the positive and the negative ideal points are identified, and then the separation distance from the positive and the negative ideal solutions are calculated. Then these are the equations which are used in this TOPSIS model for generating this information. And here this is the table showing the weights that were given to each parameter. The highest weight was given to the pounding possibility, followed by the percentage of masonry buildings, and the lowest weight was given to the shape of the shape of the building. And these are the values that are generated from the generated from the TOPSIS model. Now coming to the results. This is the map showing the digitized building footprint map of the Srinagar ST. Approximately about 250,000 buildings were mapped and classified during the field. This is the map showing the average height of the buildings in each ward, the highest being 9 to 9.68 meters. And this is the map showing the distribution of masonry buildings in the study area. Approximately 98% buildings of the ST are masonry structures, making the ST more vulnerable. And this is the map showing the distribution of irregular shaped buildings across the different wards of the ST. The analysis reveals that approximately 3% of buildings in the city are having plane irregularities. The analysis also reveals that the residential buildings usually have a regular rectangular shape with 4 sides, and some of the buildings of schools, colleges, hospitals, or some government offices have irregular shapes, and that of a letter O, L, U, and T and H. And this is the map showing the buildings with the chances of pounding. Approximately 65% of the buildings across the city are showing the pounding possibility. And it is evident from the map that the center of the city is showing the maximum chances of pounding due to the reason that the buildings are densely packed. Similarly, the building density map also shows the similar pattern, with the center showing the highest building density of more than 15 buildings per acre. This is the map showing the road network of Srinagar city, wherein we have classified the roads on the basis of their widths into 3 different categories, that is less than 8 feet, 8 to 16 feet, and more than 16 feet. It was found that the roads or streets with less than 8 feet are considered as potential sites of blockades. Also, it is pertinent to mention here that the center of the city is relatively having the denser road network, though the roads being narrower makes these areas more vulnerable and posing hindrance during the post-earthquake evacuation and mitigation processes. So to prepare the overall vulnerability map of the city, all these layers were integrated and the weights were assigned to generate the earthquake vulnerability map of the city. So this is the ward-wise structural vulnerability map of the Srinagar city. The GIS-based analysis of structural vulnerability using a coupled model of AHP and the TOPSIS classified the wards into 5, that is the very high, high, moderate, low, and very low levels of these vulnerability. Now coming to the concluding remarks, that the presented vulnerability zonation map divulges that very low category covering 32.44% of total area of the city includes 10 municipality wards. Low category covering 32.52% of the total area includes 17 wards. Moderate category covering 28.02% area includes 19 wards, and high category covering 5.72% area includes 14 wards, and very high category covering 3.15% area includes 9 municipality wards of the city. The highest vulnerability of the central wards is attributed to their high pounding possibility, building density, narrower roads with less or no open or green spaces. Green or open spaces serve as evacuation places. Therefore, the avoidance of more construction in these areas and development of these spaces is strictly recommended. The study also emphasizes that the need for planning emergency response to reduce casualties by permitting rapid, selective, and effective use of the resources and retrofitting schemes to protect human life and economy. Thank you.
Okay, thank you. Now paper is open for discussion. Any questions?
Thank you, Medhar. It is a really very useful study, and let us hope that such kind of study and their results are available for the policymakers, so they can take decision accordingly. I have got a small query, rather just can you suggest, because in your study you are considering the opinion of experts,
Yes.
and that can be a subjective decision, and there you are using AHP, correct? And so
Yes, sir.
can you suggest something that we can make it more objective? Because opinion may vary from expert to expert, and I don't want that this kind of qualitative work should be done. So whether you can suggest any method where you can do this quantitative analysis.
Sir, basically, there are models that have done this vulnerability thing, but due to the dearth of this available information with us, we can't go for that. So we are stuck with these parameters, and we go for these expert opinions there.
Yeah, in fact, both the things are important. The
Yes,
kind of work which you are doing, that is also important. Okay, thank you, Midar.
Thank you, sir. Thank you, sir. We will proceed for the next presentation by Jassia Bashir. Jassia Bashir, please start your presentation.
Yes, ma'am. Good afternoon, everyone. This is Jassia Bashir. I am a PhD student at the Department of Geomatics, University of Kashmir. Today, I am going to talk about climate change scenarios over Upper Indus Basin by the end of 21st century. First, I would like to give a deep background about the study. Climate change has been a cause of concern among a large section of society for its far-reaching consequences on food, water, and energy security. This has led to widespread interest among the scientists and policymakers to investigate the impacts of climate change on various sectors vital for lives and livelihood of people. The scenario is no different in Upper Indus Basin, which encompasses uh, Kashmir, Jammu, and Ladakh region. The indicators of climate change are loud and clear. The temperature is showing a significant rise, although there is no change in overall precipitation. However, the form of precipitation is changing. Also, the extremities associated with climate change have increased manifold from the last few decades. The temperature is further projected to rise by the end of 21st century. This rise in temperature together with change in precipitation may pose a serious threat to the key economic sectors of the region. Although we don't have a direct control over climate change, however, proper adaptation and mitigation strategies may minimize the consequences. Uh, since the meteorological observations in the study region are scanty, as can be seen from the figure that there are 8 meteorological stations distributed across the region for which long-term data is available. 6 of these stations are situated in the Jhelum Basin. Owing to the scanty network of meteorological observations, climate models can assist the policymakers for preparing robust mitigation and adaptation strategies so as to safeguard the pristine environment and economy of the region. This study is focused on the Upper Indus Basin since the comprehensive assessment of climate models over the region is missing. This study shall provide a high resolution and reliable baseline data for the local scale impact studies. This study shall further help and assist policymakers to develop robust adaptation and mitigation strategies so as to combat the climate change. Keeping in view these facts, the study was divided into two main objectives. First is the high resolution multimodal comparison of climatological variables to determine the most plausible climate change scenario in the Upper Indus Basin. Second is the statistical downscaling of climatological variables from the high resolution climate models. First of all, since the climate models, these are often associated with the uncertainties which mainly creep in due to future forcings and are more predominant in mountainous regions like Upper Indus Basin. Therefore, the selection of the suitable and plausible climate change scenarios is a crucial step while carrying out the local scale impact studies. Here, first we extracted the temperature and precipitation simulations from a set of 5 climate models organized under the coupled model intercomparison project 5. The temperature and precipitation simulations were extracted for the baseline period of 1980 to 2005, which were then compared with the observed data obtained from 8 meteorological stations. In order to assess the agreement between the observed and simulated data, we used a set of statistical tests like correlation coefficient, root mean square error, relative bias, and Nash circle coefficient, based on which the best fit climate model representing the climatological parameters of the region was selected. The selected best fit model was then downscaled in order to minimize the uncertainty associated with the climate model. So the comparative analysis of the simulated and observed temperature revealed that all the models were coherent, showing a good correlation except for GFDL ESM in simulating the temperature over the region. However, GFDL CM3 showed lowest relative bias of all the among all the participating models, lowest RMSE of 1.5 and lowest and NSE of 0.7. Similarly, the precipitation, simulated precipitation wire was validated against the observer data, and it was found that all the models showed a poor correlation. However, GFDL CM3 again showed lowest bias, though this bias was still significant. However, it was lowest among all the participating models. Also, GFDL CM3 showed lowest RMSC of 7.7 and an NSC of 8.8. So it was concluded that GFDL CM3 was coherent in simulating both temperature and precipitation over the region, although the precipitation simulations are less reliable compared to the temperature. Since though GFDL CM3 simulated both temperature and precipitation was good in simulating both temperature and precipitation, however, there was still bias which needed to be minimized. Therefore, we used statistical downscaling method. Statistical downscaling, it establishes the empirical relationship between the local scale and the large scale atmospheric variables and produces site specific results. In this study, we used Arts and Ruger's method. This method downscales we downscale the simulated data for the baseline period of 1980 to 2005. It corrects the GCM data such that the average and variation in the reference data set matches with the observed data. First, the averages and variations were calculated for the reference data set. Then the correction factors pertaining to average and standard deviations were calculated using these two equations. The correction factors were further used to downscale the monthly GCM data using this equation. The downscaled simulations were then validated with the observed data, and it was found that the bias was considerably reduced at each station, as can be seen from the table. Also, the average bias was reduced from 39% to 2.9%. RMSC was reduced from 1.5 to 0.3, and also this NSC was improved from 0.7 to 0.9. In case of precipitation, the bias was reduced considerably from 80% to 13%. RMSC was reduced from 7.7 to 4.1, and a better NSC of 1.1 also shows the efficiency of this statistical downscaling method. The downscaled projection climatic variables were then projected by the end of century, and it was found that the temperature is showing a significant rise for all the three regions, that is for Jhelum Basin, Chenab Basin and Indus Basin. For Jhelum Basin, temperature is projected to rise by 3 and 5 degrees Celsius under RCP 4.5 and 8.5 scenarios. For Chenab Basin, the temperature is projected to rise by 3 and 4 degrees Celsius. And for Indus, the temperature is projected to rise by 4 and 6 degrees Celsius. In case of precipitation, the precipitation is projected to show a marginal decrease of 0.8 to 3.4% for Jhelum Basin, and the precipitation is projected to decline considerably for Chenab and Indus Basin. So the main conclusions that were drawn from the study are that GFDL CM3 outperformed all the participating models in representing the prevalent climatic conditions of the study region, especially the temperature variable. The inherited bias in the best fit model was reduced considerably using statistical downscaling method. The temperature is projected to increase significantly under different climate change scenarios by the end of 21st century. The Ladakh region, which is in Indus Basin, is projected to be the warmer region, followed by Chenab and Jhelum. The precipitation, on the other hand, is projected to witness a marginal decrease in Kashmir region. However, in Jammu and Ladakh region, the precipitation is projected to decline considerably. The projected climate would have significant impacts on various ecosystem services, products, and the dependent livelihoods. Thank you.
Paper is open for discussion and questions.
No question from me.
Okay, thank you, sir. So should I proceed for next? This is our last presentation by Hena Shafi. Last presentation of this session. by Hena Shafi. Please start your presentation. Hena Shafi, are you going to present?
Yes, ma'am. Ma'am, first presentation is currently sharing. That is why I'm not able to share my presentation.
I am just unsharing the presentation.
Yeah, you just remove your presentations.
Yes, I am just.
Esteemed Chair, Dr. Shakila Madramshu sir, and the co-chair, Dr. R.K. Rajak sir, and my fellow participants, a very warm good afternoon to all of you. I am Hena Shafi, and I'm currently pursuing my master's degree of Geoinformatics from University of Kashmir, and I'm here going to present my study in student category, and the topic of my study is assessment of drought conditions or Kashmir Himalaya using drought index, decile drought index, and ARA5 reanalysis data. First of all, I'm going to give a brief introduction about the reanalysis and the drought. As reanalysis is a systematic approach for producing data sets for different climate modeling and research on, or a scientific method for developing a comprehensive record of how weather and climate are changing over the recent decades. Its products are usually extensively used in climate research and services, including for monitoring and comparing current climatic conditions with those of past, identifying the causes of climatic variations and the changes, and also helps in preparing the future climatic predictions. As reanalysis helps in preventing the gaps of climatic variables over the severe and the unreachable zones of Earth. And I have used the ARA5 reanalysis gridded data set for my study, which have a global horizontal coverage with horizontal resolution of 0.1 degree into 0.1 degree, approximately considering a 9-kilometer area, and it gives us a temporal resolution of hourly data, and the data which ARA5 gives is from 1950 to present, which was recently updated. First, it was giving the data from 1981 to 2020. As we know, drought is a recurring feature of the climate in most parts of the world. However, these droughts are becoming more extreme and more unpredictable because of the various climatic changes which are we facing from the recent decades. Climate change affects multiple factors associated with droughts, such as how much the rain falls and how fast the rain evaporates because of the increasing temperatures. It is said to increase the severity and frequency of droughts in the recent years, although the Kashmir lies in the Himalayan region, which is considered as the Himalaya is considered as a water tower of Asia, but still in Kashmir we are still facing frequent water scarcity, mainly in the autumn seasons, which is so much of a concern for the region. Therefore, we used several drought index to identify the drought years for a baseline of 40 years that is from 1981 to 2020. Currently, I have only used the decile in this study here. The main aim of the study is to analyze the characteristics of drought over a period of 40 years from 1981 to 2020 using the ARA5 reanalysis data over the Kashmir Himalaya, India. The aim further try to evaluate the efficiency of ARA5 for representing the temperature and the precipitation, which are the variables of our climatic variable regimes over the mountainous regions of the Kashmir Himalayas. ARA5 land reanalysis data for the baseline period of 1981 to 2020 was then validated against the observed climate variables which were derived for the 6 meteorological stations lying across the valley. The study area is the Jammu and Kashmir, which lies in the northernmost state of India, situated between 32 to 37 north latitudes and 72 to 83 east latitudes. Geographically, the state of Jammu and Kashmir is divided into 3 distinct climatic zones. That is the humid subtropical region of Jammu, the temperate region for the Kashmir Valley, and the cold arid zone for the desert area of Ladakh. The state of Jammu and Kashmir therefore lies between the hot plains of Jammu provinces and the cold dry land tables of Ladakh. Here the map shows the position of the 6 meteorological stations which lie across the valley. The methodology of my study is I have used the reanalysis climate data set, which after pre-processing, extraction, setting, and converging and stacking it daily. Then I have compared the precipitation and the temperature variables of the climate data with the 6 observed stations lying across valley, that is the Srinagar station, Kufara station, Kazigund station, Kokarnak station, Pahalgam station, and the Gulmarg station. And then I have done some of the statistical tests between the reanalysis data and the comparison observer data, like correlation coefficient, relative bias, root mean square error, and Nash, for predicting how much the two datas are showing the results. And then I have used the reanalysis data for my drought index, that is a decile drought indices. These are the comparisons graphs of my observer data for precipitation from 1981 to 2018 for the different stations across the valley. And these are the comparison of ERA5 land observer data for temperatures across the valley.
Yes.
This is a result for the statistical analysis of the two, precipitation and the temperature variable. The different stations shows a different correlation coefficient, relative bias, and root mean square error, and Nash. The precipitation shows the highest correlation for Gulmarg and the lowest for Srinagar, and the relative bias is for highest for Kazigund and the lowest for Pahalgam, while the root mean square error is comparatively higher in Gulmarg and the lowest for Srinagar, and the Nash is overall showing the nice fit for the precipitation. While for temperature in this variable, the correlation coefficient shows highest value for Kokarnak and the lowest for Kufara, while root mean square error shows highest for Kufara and the lowest for Gulmarg, and the relative bias shows highest for Kufara and lowest for Kokarnak. The temperature projections from the ERA5 were found to be in good agreement with the observation, showing the average of correlation coefficient of all the stations of about 0.63%, and the average relative bias for the temperature was 0.19, and the average mean root square error for is of 2.33, and the average Nash is of 0.84. And while the precipitation projections, on the other hand, showed poor agreement with the observations, the average correlation coefficient is of 0.59, and a relative bias is of minus 0.21, and root mean square error simultaneously for 236.16, and Nash of minus 0.81. Further, I have used the ERA5 data for identifying the different drought years between the time period of 1980 to 2020, for which I have used the decile drought index, which mainly uses the frequency, which helps in characterizing the frequency and severity of meteorological drought in the study area using the annual mean precipitations. So the table shows the different drought years in different stations. These shows mainly 10 years of drought from 1981 to 2020 years, where the severity were mainly the high severe droughts were for the year 2004, 2007, 2001, and 2016 in Srinagar. Similarly, for other stations, there were also the 10 years of drought. The index was then validated for Srinagar station with the stream flow of the Jhelum observed at the Srinagar, showing the following years of same showing the same years for drought, as the stream flow of these years were comparatively lesser than other years. The years which are same for Srinagar showing drought are 2008, 2001, 2009, 2000, 2016, and 2018. Lastly, the conclusion. In the study, we evaluated the efficiency of reanalysis data for the Himalayan Kashmir for comparing it with the observed data for the 4 decades period or 6 meteorological stations across the valley. The temperature shows a good agreement. Temperature projection shows the good agreement, while the precipitation shows the poor agreement between the observed and the reanalysis data, having the relative bias of 0.19 for temperature, and for precipitation it shows a relative bias of minus 0.21. Out of for the drought, it is concluded that out of 39 years, 10 years were identified as drought years with increasing frequency and severity, which is an indicative climate change. The study will help us to develop sound policies to mitigate and adapt the changing climate in Kashmir, Himalaya, and also help us to understand the emerging climate scenarios for the future. Thank you.
Now paper is open for discussion. Any questions?
Yes, Hina, it is
sir.
I'll tell it's an excellent study. I have some minor queries. Basically, it was 39 years or 40-year analysis.
Humanities,
So,
humanities block there.
it was a 40-year analysis, but because
40.
of some observational data, we don't have the
Okay.
2020 full observational data. That is why
Okay.
I
That is
have
why you are telling. Okay, 39.
39 years.
Okay, nice. Now there are different indices which basically scientists have used for assessing drought conditions. But why you have used this decile drought index? Has there any study which tells that for Kashmir kind of terrain, this index should be used for assessing the drought?
No, sir. Actually, I am currently using different indices also, but for now I have only used the decile as I'm currently pursuing my masters and I'm undergoing the study. That is why the decile were completed, so I only presented decile. I have also used the SPI for the drought index, which I am currently doing my work on that indice.
Okay, but do you have any idea that for this kind of terrain and the kind of data which is available with you, which index should be a better index?
So I'm currently mainly focusing on we have different drought indices. I'm currently focusing on that indices which which use those variables which I have, like SPI that also uses the precipitation and the temperature variable. So I'm using only those variables for which I have the data.
Okay, great. And you were telling that data, this ERA 5 data, it is available 1950 onwards, but you have used 1981 onwards only. Why?
Yes, it was updated back 1 month ago. That is why I have only used the data from 1918, as I'm doing my work from last year. That is why. And in future, I will expand it to 1980.
Okay, good. I wish you all the best. Thank you.
Thank you, sir.
Thank you, sir. We were having a total of 6 presentations, but one paper was not presented in the session. So we have 5 presentations in our session. So, sir, I want that you brief the session.
Ramsu sir, whether you would like to brief or?
Yeah, you brief, because I know about this work very well.
Okay,
Then
yeah.
I will make 1 or 2 minutes concluding remarks.
Okay, right. So basically, there were 5 presentations which were made in this session. And the first presentation was assessing the soil erosion changes in the greater Himalayan watershed using ICONOM model, which was presented by Farheen Qazi. And it was an excellent presentation and a very good study using ICONOM model. She has used ICONOM model for Kargil districts and she has used the data from 1992 to 2020, right? Then a similar kind of study was done by Abida Basir and for the same study area, but a different approach. So basically, these 2 studies, they were on assessing the soil erosion changes in the greater Himalayan part, that is Kargil district. Then third study was on earthquake structural vulnerability, and that was presented by Midhat, and she has nicely used AHP and TOPSIS for assessing the structural vulnerability over the Srinagar city. And my only concern was that while studying this kind of thing, to reduce the subjectivity, what kind of objective analysis may be incorporated. Obviously, there are many other studies people do, and she is aware of it. So obviously, in future, we should go for quantitative analysis, and wherever possible, obviously, we have to do qualitative analysis also. Then next study was on climate change scenario over Upper Indus Basin, and that was presented by Jasia Basir. So that study was a very good study, and she has used a multi-model approach, and then she arrived for best fit climate model for a different region. Especially she has covered Jhelum, Chenab, and Indus regions. It was a good study. And the last study was on assessment of drought condition in Kashmir, and she has currently used the decile drought index. And along with that, she has used ERA 5 reanalysis data, which is of 9-kilometer resolution. So right now she has used data from 1981 to 2020. So these are the 5 presentations were presented in this session. All the presentations were nicely presented, and I thank you, the presenters, and good afternoon now, Dr. Romsu. Now over to you.
Yeah. Yeah, thank you very much, Dr. Rajat. And also thank you very much, Dr. Meenakshi, for nicely coordinating this session. So it rarely happens that, we have almost all the presentations and then we keep the time also. So that's why I have some time to speak for 5 minutes or so. And I think, one where girls here, so that very nice, and but unfortunately all of them were from one institute. It would have been very nice really if this could have been distributed and different other sessions also, so that they could have also, the other people could have also see, because good thing is that 3 of the presentators that presented are still in masters. They still have about 6 months to improve their work, and 2 of them are the PhD students. And I always encourage, and I feel that now since last few years we have joint symposiums, this is the best opportunity for the students to make presentation of the work. And I'm sure they will be, though this was a very homogeneous session, but I encourage you to be in every session that interests you, so that you can evaluate your work with the others in the field, those who are, either students or scientists and all that. So for a student, this is the best opportunity to learn and improve upon their work. So I always, feel that all of us, whether scientists or senior scientists, junior science students, have to participate in these type of symposia at the national level. And I'm very happy all of you made, very good presentations, as Dr. Ajak was also saying. So it was very good. The presentation sequence was very good. The timekeeping was very good, and content is also good. And there's always scope to improve the content, as Dr. Rajik was also suggesting that there's always scope. So I think with these, this comments, so it was just addressing the topic disaster management and climate resilience. We had land degradation is the slow disaster, and we have been working with the SAC for a long time on land degradation also. So these are, these 3 disasters, and they are very relevant to Jammu Kashmir and Ladakh region. There is a land degradation, is climate change, and earthquake. All of you brought that very prominently, the importance of these studies. So with these, comments, I wish all of you a very productive ISG and ISRS symposium. You still have almost 1.5 days left. So I encourage you to be, in every session, wherever you want, wherever it interests you, so that you can learn more and better. Thank you very much. Over to Dr. Meenakshi.
Thank you, sir. Thank you, sir. So there are very nice presentations and we get very good comments of chair and co-chair of the session. Now we will present just to honor you memento in virtual mode. Firstly,
Memento.
mementos. Firstly, we will present the memento to co-chair of the session, Dr. D.R. Redder.
Thank you so much, man. Thank you.
Just a minute, sir. Just a minute. I think there is some problem. I just asked him.
Technological delay.
Yeah, it's the technological delay.
In fact, COVID has taught us a lot, and
Yeah.
this doing things online is one of them. Otherwise, we were not that that easygoing as far as online things is concerned. But now we know, obviously, certain technical mishap will keep on happening. That's not a problem. But we have really learned a lot.
Yeah, this is the only good thing that came from COVID, that we are able to communicate well between us.
Yes, yes.
Sir, I think this is visible to you now.
Yeah. It is coming up very prominently.
Yes,
Okay.
yes.
So it's for our co-chair.
Okay.
Thank you so much. Thank you so much.
Okay. And this is for our chair of the session.
Okay, thank you very much. Thank you. I received it, online.
Okay, thank you, sir. Thank you. Thank you so much, sir.
Thank you, Dr. Meenakshi. Thank you, ISG and IRS Symposium Committee. Thank you for giving us this opportunity. And once again, I thank all the presenters and all the authors who, did all these remarkable studies. And I wish all them all the best.
Thank you, sir. Thank you, sir. Thank you for being with us during the session. Okay, thank you, sir.
Okay.